Good evening, everybody. Welcome. It's 7 o'clock and it's time to begin. Welcome to our presentation tonight, our invitation to have a very, very big, long dialogue about the moon and lunar eclipses and phenomenon like that. And I'm very excited to finally get to the program. We saw this coming about 3 or 4 months ago and really wanted to have a chance to just get a whole bunch of people gathered together all on the same subject. And you're going to see, if you stay with us for the full 2 hours and 15 minutes tonight, we have many partners and many players that are going to be with us and really just taking it all in. Just to get everybody sort of oriented, my name is Rick Alling and I work for the School of Earth and Space Exploration at Arizona State University. We are on the Tempe, Arizona campus, and you saw that little video leading into the program. That's just sort of a little bit of excitement about some of the things we do. But tonight isn't just about us at ASU and the School of Earth and Space Exploration. We've got other partners in other places that are going to take us along this journey of the total lunar eclipse of May 15th. And so I'm going to spend the first little while introducing a bunch of people and a bunch of teams that we've got people spread around really all over the world, literally. And so you'll be seeing my view a little bit. This is from a station. I'm up at a friend's house up in North Phoenix, Cave Creek area. You can see the mountains in the background. That really is where the moon is going to be rising here in about 15 minutes. I think we should start to see it. And so so that'll be kind of part of the thrill here is like we'll watch it get dark. We'll watch the moon enter the scene, and then we'll watch the moon go into eclipse as we're sort of just doing this live. I think that's going to be a lot of fun. But again, it's not just me. So you'll have my view from up here. I got a telescope up here as well, so we'll see that. But not in any particular order. I wanted to also introduce, we've partnered this time with the very, very great, wonderful folks at Lowell Observatory. So John and there's Kevin and John. So Lowell Observatory is also up in in Flagstaff, and they'll be able to have a chance to really introduce themselves in a big way tonight as well. But Lowell Observatory is also doing something similar. They're doing some broadcasts, and they have some people coming up to visit them on the Lowell Observatory campus that they're taking on the total eclipse of the moon tonight in a very special way as well. And so John and Kevin are going to be with us. Hey, say a little bit about what you got going on up there.
Well, it's great to be part of this program. He's John.
He's Kevin.
And we're a couple hours north of you and a few thousand feet higher. And we've got both on-site programs and virtual program going on tonight. On the on-site program, we're expecting more than 1,000 people here. And we're not sure what the clouds are going to do, but we've got all sorts of educators and astronomers on hand to show views through telescopes, views without telescopes. We've got food trucks, we've got drink trucks, we've got activities going on. It's really, it's a party. It's a party to celebrate the sky. It's really cool.
I know, and what a great excuse to throw a party. I think this is absolutely amazing. So and you guys look like you're so ready for it. Good for you. So this
yeah, we've been waiting. The last couple total lunar eclipses we had in Flagstaff were like 3 in the morning, and that stinks to try to view at that time. This is about as well timed as possible. And John can tell you about the online program we have, because we have not only the stuff here, but online that's going to be spread across the world.
Yeah. So yeah, for all the lunatics out there that are going to hang out with us, we're going to be live streaming the views of the moon, but we'll also be seeing video segments talking about the eclipse and talking about the moon from some of our educators and supervisors here. I'm going to be feeding my dog moon-shaped cookies to show you every once in a while. We're going to have plenty of Q&A, so in the comments, ask us questions, you nerds. Yeah, and it's going to be a good time. We're going to be streaming kind of all night through totality, and then deep into the late evening.
Good. Well, good for you guys, and we'll be back. So the way the show is going to run tonight is we're jumping a little bit around between different players, and so you'll see Kevin and John again here in a minute. But I'm going to introduce some other people. So aside from having the Lowell Observatory and Flagstaff, Arizona join us, we engaged some people from the country of Chile, the Astronomical Society of Chile. And so if I could get, here he is, Alvaro Rojas. Thank you very much. So I just think this is, I sort of had a dream about this like 6 months ago. I said, what if we could actually sort of see the moon from two different directions? Now, let me explain to the audience. So we'll be jumping around quite a little bit, and we'll be seeing the moon from lots of different places, in fact, the southern hemisphere as well. But the Chilean audience that's watching us tonight is also mostly Spanish speaking. So I'm going to give Alvaro and their team some opportunities to sort of like jump in and do this. So if you sort of like are watching for a little while and you find out we're suddenly speaking in Spanish, you'll know why, because there is a really wonderful Spanish audience down in Chile that's kind of doing the same thing. So Alvaro, how's it going? What's happening down there? It's already dark for you, right?
Yes. Hello, everyone. So I'm Álvaro Rojas. I'm speaking from Santiago de Chile. So here it's already dark since more or less 3 hours ago. So moon is already rising over the Cordillera, our nice mountains over here close to Santiago and along all the country. And we are waiting for sharing with you the images. We are retransmitting from the Atacama Desert. So even like 400 kilometers from here to the north. So the place where all the or most of the large telescopes in the world are sitting. So we have a small telescope there, which is transmitting for all of you a live image of the eclipse from here, from the southern hemisphere.
Okay, this is a little bit non-scripted, so I'm going to ask you to do something. Just tell me if you can't do it. But is it so? I'd like to give you an opportunity also to talk to your audience. So if you want to introduce, kind of myself and what we're doing tonight, if you want to do that in Spanish, this would be a good time to do that. But also, can we have a little view of your scope? Do you have it on the moon?
Yes. Okay. So I can shift for 30 seconds to Spanish. So I
that would be great. This was a great opportunity. Yep.
Ok, so, hola a todos, buenas noches. Soy Álvaro Rojas del Instituto Milenio de Astrofísica y representando también la Sociedad Chilena de Astrofísica. Les hablo aquí desde Santiago de Chile. Ya está oscuro acá, a diferencia de Estados Unidos que aún están mostrando imágenes del día. Y lo que vemos acá es la transmisión en vivo que tenemos desde el desierto de Atacama, ya de noche, de la luna comenzando dentro de poco a entrar en la sombra de la Tierra. Así es que estamos prontos a empezar el eclipse y los invitamos a que nos acompañen en esta transmisión conjunta.
Excellent. So this is your view. There's your moon. It looks just like my moon.
Yes, actually, our moon, like backwards, no respect to you. I mean, the orientation of the moon is probably not the usual for you.
No, this is actually, this is how we would see it. This is how we're going to see it up here too. I'm anxious though, at some point we'll get some shots. It hasn't just for the audience. We're still waiting for the moon to rise. And so Chile, the country of Chile in South America, is essentially the Eastern time zone of the United States, right? So the East coast of the US is the West coast of South America. And so they already are in the dark. The moon has already risen. And but we are all, they and us, waiting for the moon to start to go into a total eclipse. And so the first thing we're going to see here, and it's actually coming up pretty soon, I would say starting at about 7:28 tonight, we'll start to see the shadow of the Earth take a little bite out of the moon. In the meantime, the moon right now is in its penumbral phase. And so what that means is that it's already partially in the shadow of the Earth. It isn't in the very deep, darkest umbral phase yet. That will happen starting in about 20 minutes. But it's already, I don't know, I mean, we don't have any reference to see what it might have looked like when it was, when it's not umbral, but penumbral. But it does look a little bit of gray to me. And that's, I think, how the moon's going to look up. It won't be its typical brightness when it arrives on our horizon. And we'll see that. But that's very exciting. That's good. That's a great view. So if you want to take some of that into Spanish, and also, can you tell us what sort of the telescope you're using here?
Yes, here the look we are having at the moon is with a relatively small telescope, not like the big telescope, large telescope in the Atacama Desert. This is a small telescope of around 100 millimeters size, the aperture. So, and this is because basically we are looking at the second most brightest object in the sky, after the sun. So we don't need actually a large telescope to get the photons, to get a nice image. So this is a small telescope with an equatorial mount and a camera which is following and compensating for the rotation of the Earth, so we can follow the moon very precisely over several hours if we wish. So it is a small telescope. It is located in an observatory in the Atacama Desert called El Sauce. So that will be the willow tree in English, And it's an observatory where many amateur telescopes are sitting. So in particular, we have this image thanks to Eduardo Latorre. So I would like to thank him publicly, who is an astrophotographer who set up this live transmission, and shared with us also to use here. So he's the guy behind this nice moon image.
And I guess you and I know this is absolutely live. So this is actually the moon like it looks right now. But I guess it didn't occur to me, but somebody might look at this and say, it's a photo. You just sent us a picture of the moon. Well, it is sort of a picture of the moon, but it's live. This is what it looks like now, right? So that's really super cool. Okay, I have a handful of other introductions to do just before we get to 7:15 and our first milestone. So thank you, Alvaro. We'll be checking back in with you every once in a while. And please feel free if you just need to stop me for a moment and sort of use the Spanish language to talk to your audience. Just anytime you want, we'll just do that. Okay.
Perfect.
Thank you. I'd like to introduce some people from the Lunar Orbiting Reconnaissance Camera. So I'm sorry, I said that wrong. Lunar Reconnaissance Orbiter Camera, and LROC. And LROC people are here today. I'm going to introduce you to Jessica Walsh, because there's actually quite a team of people from the camera here today, and they're going to be participating with us as well, talking about moon images, moon mapping, also all things research on the moon, and some things that are coming up. Jessica, how's everything going tonight? Mariah, how are you doing?
Going well. We're coming to you. All of us here are actually in the Science Operations Center for LROC right now.
That's excellent. Good. And so periodically during the next couple hours, right, we'll be watching the moon. We'll be inviting you to go outside and look at the moon yourself periodically. We're keeping this kind of loose. This is a party, as we already established. But just periodically, we're just going to kind of like dip back over to LROC, because they have a whole bunch of really wonderful things to show us. And there's also resources that they can show you, things that you can look up on your own computer, just understand what they're doing and why their work is important, and all of that kind of stuff. So welcome, LROC guys. I'm really glad to see you there. Hey, I don't know if Kevin O'Donnell can just jump in right now. If you're in a position, can you hear me? And are you ready to jump in? Hey, Kevin.
How are you?
So I'm going to keep Kim really busy, sort of like pinning whoever on the screen that we can. So Kevin, you're up in North Phoenix, but you got a totally different rig there. So you're on cameras and that kind of stuff, and you're an astrophotographer. And what do you hope to get out of the night?
Yeah, Rick, thanks for everyone who's joining. Obviously, people have choices. I'm glad there's so many people interested in astronomy. And so what I'm doing is I'm a photographer, professional photographer and videographer by trade during the day. And at night, I'm an astrophotographer. And so I have a pair of cameras set up here and an open lot, and looking or hoping for some clear skies. I have similar skies to you.
I know you can see the clouds in the background a little bit. So yeah.
I'm in North Phoenix, so a little different spot than you, but be contending with some of the same stuff. So my hope is to take some deep sky shots with this longer lens I have, and some wide angle ones with this camera that I have as well.
Excellent. And so we'll get back to you in a little bit. We're going to let it get dark. Let's let the moon get up, and we'll sort of like, but Kevin, we'll just be kind of trying to reach you and see what you're finding out, and some of the images. And then I think I mentioned this too in your email before. We were hoping to get you back next Wednesday to show us some of the images that you captured tonight, if it works out. So,
great.
So I hope we can do that. The last introduction I want to make is Maitreya. Are you guys out there? So Maitreya Sanoe and Armandala and Mahar, I think they're out in the field. Hey guys, how you doing?
Pretty good. We're all set up. I don't know if you can see it, but it's right here.
We can see it. That's great. Okay, so this is Tempe Town Lake. I know that, but nobody else does. So
Yeah.
do you guys have a pretty good look? Hi Armin, how you doing? Do you guys have a pretty good view of the eastern horizon over there? Can you show us where you're gonna be looking?
Yeah, it looks pretty good. It's not a problem. There's some clouds, but I don't think that would be an issue.
Okay.
At max, it's like 5-degree cover. So
And
we'll have a good look. Yeah.
do you have any idea what temperature is out there right now?
Probably high 70s or 80s. I don't know.
I think it's a little higher than that, but good. That's optimistic thinking. Okay, so you guys are students at ASU. All of you are actually work for us in School of Earth and Space Exploration and our outreach program. And because of COVID, we haven't had a very sophisticated telescope kind of program out for a while. But I know all of these guys are interested in doing that, deploying telescopes and get them in front of people in crowded places. And so we found a location on Tempe Town Lake where they can watch this moon thing happen, and hopefully there will be a bunch of dog walkers and people out to take a look with you, I hope. So good luck. So is everything working all right?
Yes, we'll start the live stream as soon as the moon rises.
Okay, that'd be perfect. We'll try to come back to you as soon as the moon comes up, and I'll get the audience oriented on what happens next and how that works. But thanks, guys. And hang tight. We'll be back with you. Okay. Thanks, everybody. Bye-bye. All right, so I think you've met some of the players. I see we've got quite an audience developed here. Here's the way the evening is going to run down. The first 15 minutes is me doing this. We just did an introduction of who's who and where this is, what's going on. And what we're going to do is just, as I sort of indicated before, we're going to have during the next 2 hours, we're going to have views from various places about this moon. We're going to try to do as many live shots of the moon doing its things as we can. I'm going to try to get you a shot of the moon rising over this horizon behind me in just a couple of minutes. And just this, so the way the Earth and the sun are going to work is that the moon rises at 7:12. That means it's probably the lobe of it is already on the horizon if you can see it. The sun is actually going to set at 7:21. So that's only, I've got my watch out, about 4 minutes from now, the sun will be below the horizon over there. And then that sets up a sequence of twilights. It'll just get darker and darker. Civil twilight will end about 7:49. There's a thing called nautical twilight. That's when if you're out at sea, you can't really tell the difference between the sky and the ocean anymore, about 8:22. And then astronomical twilight happens just around 9 o'clock tonight. And that's when the astronomers come out to play. So the whole moon activity, all of the eclipse sections and how that transpires is going to happen during that period. So things will get darker, we'll be able to see better as things go along, and then we'll kind of get views of the moon, and we'll be cutting back and forth to different people. We'll have presentations from the Lunar Reconnaissance orbiting people. I'm just about to say goodbye to John and Kevin up at Lowell. They've got other things they're going to do along the way, so they're going to disappear for a little bit, but we're all joining back together at 8 o'clock. And at 8, the moon should be fully up. The moon should be well into its journey into full eclipse, and we'll actually have a combined audience, all of us together for a period of time. So that'll be kind of fun. So for you, what I want to do, I'm about to cut away and let Catalina kind of have the voice in Spanish here for a little bit. But for you, stay tuned, come and go, stay with us if you want, watch what we do. There's a way for you to participate as well. I think some of you have discovered it, but in a webinar format, you can't do chat. We don't do that part, but you can do question and answers. So push that little Q&A button and just sort of, you just ask anything you want, comment about anything you want as we go along. If we move too fast and we need to sort of like clarify and comment, stop us and let us do that. We will be doing some poll questions for everybody in the audience to participate in a little bit. So what I'm going to do now is I just wanted to say, John and Kevin, thank you for joining. I'm glad you're part of the team here. We have the live feed from Lowell Observatory, and we'll be seeing that as we go into the moonrise here in a couple moments. And then, like I say, John and Kevin and we'll all be back together again at 8 o'clock for about 15 minutes for a joint presentation. So we'll be doing that. Catalina, if you'd like, this is probably, and or Alvaro, if you'd like, I'm going to sort of be adjusting my telescope and looking for the moon rising over the horizon there. This would be a really great time to just kind of just touch base with your Spanish audience and give them a little update on what we're doing. Thank you, guys.
Okay, so well, I will switch again a little bit into Spanish so we can explain what we are looking from here, from Chile. Entonces, bueno, para la audiencia que nos está siguiendo, el eclipse va a comenzar dentro de poco. De hecho, el eclipse parcial comenzará ahora casi a las 10:30, o sea, en un rato más, horario de Chile. Más o menos, casi a las 11, más o menos unos minutitos antes de las 11, la luna va a estar parcialmente cubierta ya por la sombra de la Tierra. Van a ver ustedes que la mitad del disco de la luna va a estar cubierto, una mitad oscura y la otra aún bastante bien iluminada. Y hacia eso de las 11:30, nuevamente horario de Chile, es cuando se completa la fase de parcialidad y comienza la totalidad del eclipse, que es cuando la luna ya entra por completo en el cono de sombra de la Tierra, que es lo que nosotros llamamos la umbra, la parte más, digamos, sombría del cono de sombra de la Tierra, y es entonces cuando vamos a ver a la luna bañada en color sangre, que es por la razón que a veces se le llama luna de sangre. En ese momento veremos ese color porque la luz que está pasando a través de la atmósfera tangencialmente a la Tierra estará entonces cayendo sobre la luna con un color rojo que es el mismo que vemos al atardecer, y por las mismas razones, porque la atmósfera de la Tierra difumina la luz azul y deja pasar la roja, y eso es lo que finalmente tiñe la superficie de la luna con este color rojo tan característico.
That's great. Thank you very, very, very much. And can everybody see my view here? And,
yes, it looks fantastic.
So I'm just going to try to get a little bit of a sharper focus on that. Hang on just a second. I'm going to climb a little bit. So what you're looking at is from my location here up in Cave Creek, Arizona, at my friend James and Liz. They have a really beautiful view of the eastern horizon, and the reason I wanted to come up here is to see exactly this view come up. So it's really, really super. You guys want to? Are you guys watching it? Everyone here. So anyway, so this is kind of one of the moments we've been looking for to sort of watch it come up. It looks a little bit sort of pink to me right now, and it just probably has to do with some color correction. I'm not exactly sure. Let me sort of like make it look a little bit more moon-like.
No, it's very pink.
Is it really pink? Oh, so I'm getting the word here that it is kind of pink. So we're going to see that, first of all, there's a lot of things going on here. Moon rise when there's a full moon is the same time as sunset. So this is pretty, the way to think about this is that the Earth is in between the sun and the moon. And so the whole mechanism that creates the fully lit moon means that they have to be opposite each other. And if that is true, then during that period of a full moon, the sunset and the moon rise are approximately the same time. And so in reality, the real full moon tonight will be actually closer to 9 o'clock, about 9:11 tonight is when it's actually its fullest. But if you're a moon observer, right, you know already that for a couple of days, the moon looks full. And it actually sort of, but from an astronomical standpoint, it's only a full moon for a very, very particular moment in time. And that happens tonight. And so the reason there's a little difference between when the moon's rising and the sun setting tonight is because it's not exactly total full. It's about 2 hours short. And so, but that's it. I can actually sort of move this around a little bit. It looks like we have some, I'm just going to try to get the horizon below there so you can see that again. Maybe I can zoom out just a little bit. so you can sort of get that full view. Hope somebody is taking some screenshots of this as we go. And see, so you can also see some darkening now down at the very, very lower part of the moon there in the, it's going to be on your screen kind of to the lower left. That is going to be sort of, this is the beginnings of that shadow thing that's coming in. So I have the moon starting to go into shadow on my cheat sheet is at 7:28. Right now it's about 7:25. So you can see that the moon, you just watched the whole thing happen live. You just saw the moon rise above the horizon. And you're starting to see it now start to go into the totality of its eclipse. And this particular process is going to take a whole hour. So we have lots of time to watch this happen. You'll slowly see parts of chunks of the moon will sort of get darker and start to move off. And other parts will start to turn more and more red as it goes along. So that's really, really nice. This is also, you might have heard, a supermoon. So I'm going to tell you a little bit more about that later in the evening. I want to kind of talk about sort of what a supermoon means and what that looks like. So for right now, I'm just going to kind of check in with my guys out at Tempe Town Lake. I just wonder, are you able to see the moon yet? And are you able to get it into a telescope view? I don't know if those guys are like, they're sort of right under the freeway, so sometimes they can't hear us very well.
Yes, we are set up, but I don't think we have a good view of the moon yet.
Okay.
So,
All right.
10 minutes.
Yep. Let me know when you get back to you.
Yeah.
I also want to introduce some other players from Arizona State here for a moment. And so we have, as part of our community outreach team, I want to introduce some of the team that is here tonight. So Kim Baptista, you might know that name. She is the one that has been kind of keeping up. She does all the paperwork. She does all the scheduling. She launches the Zoom thing. She is our host tonight. And she kind of helps with this particular part of outreach, along with myself and another colleague online is Meg Hufford, and a fourth colleague online is Alicia Hyatt. And so the four of us are the staff members that do the community outreach on the ASU campus. And we have ways for you guys to come visit us, and we have ways for you to participate with us in lots of different ways. This is just one of them. And so both Meg is with us tonight to help field questions and keep us on track time-wise. Kim is here to deal with the technical issues and keep the webinar going. And then I introduce you to the students at the lake, but another really key student on board tonight is a young man named Alex Blanche. Alex is working in the background. He will be receiving feeds from other locations. And he also is working to question and answer in the background as well. So, so I couldn't have asked for a more spectacular show up of the moon coming up over that horizon. I am going to take another moment and I'm going to ask, first of all, if we have a Lowell feed, if we can see, they were also going to be looking at moonrise above their horizon. I just wanted to see if we actually have that. Alex, do you have something? There you go. Oh, it looks cloudy in Flagstaff, I guess, huh? Look at that.
And just a few seconds ago, it was nice and clear. These just have come up just in the while you were talking about it.
So were you able to watch this sort of rise as you were watching the rise over here at the same time? Did they come up about the same time?
You know, this one was kind of already seemed to be over the horizon between the telescope, and by the time it started, it seemed to kind of be already on a head start. So we didn't get to see any rising. It was kind of fully out there and ready to go by the time it started.
Okay, that sounds really good. Excellent. I just realized I have to plug something in. And then let me check back with the team on the lake already does that. So let me ask Kevin O'Connell, are you still on board?
I am. Still too low for me, Rick.
Still too low. So you have the mountains that are sort of like over New River on the background over there. Is that right?
Yeah, I did try to find a clearing, so I definitely have a better perspective than I would, that some people have, but I probably still need another 20 or 30 minutes before I can show something.
All right. And then let me switch back to Alvaro in Chile and your telescope. Are you seeing the same thing down there as far as, doesn't it look to you like we're already starting to get some shadowing on the lower left side of my image here? Is that right?
Yes, it looks like the moon is already entering the umbra, no? So starting already the phase that part of the disk is getting dark. Of course, from here, probably the contrast is better because it's already night since few hours, no? But
Yeah,
I
so
can
you
see
can,
in the image you are showing that we are all looking at that it's really getting dark, no, in one side of the moon.
it totally is, isn't it? Do you have your view? Can you show us real quick on the same screen? Maybe we could we can pin both views.
That would be fantastic if you can show both. We can compare
Yeah,
actually.
I think so.
how they
Yeah.
look.
So go ahead and launch your view of the moon. Let's just look at the two of them together here. I'm just trying to get mine centered just right. I also wanted to, while we're waiting, to ask Kim and Alex and Meg, if anybody has any questions you want to bring forward, this is also a good time to chat with the audience and see how they're doing and see what's going on in their world. And time for me to.
Yes, Sam E would like to know, what is your favorite home telescope for a novice astronomer?
Oh boy, that's, I get asked that a lot and I don't really have a very good answer.
Loaded question. Yeah.
So Sam, here's what I'm going to suggest you do. This is what I kind of tell everybody about this. There are many telescope clubs, amateur astronomy clubs in town in the Phoenix area. And all of them, oh, look, here's some sort of cloud coming into my view here. Look at that. So it looks kind of spooky, doesn't it? All of them have viewing nights, and all of them are full of, they're just loaded with people interested in telescopes just like you are. And so not only will you get to talk to people that sort of picked their telescope for a certain reason, but they'll actually be able to show you, what it is and why it's cool and why they like it and why they picked it and how much it costs. So I'm going to say, I'm not going to recommend one for you. Sorry about that, but I am going to recommend you pick one of any number. I think there's 5 amateur astronomy clubs, and they just love to do exactly what you're talking about, and they'll help you find exactly the one you want. In fact, sometimes they actually have, amongst their club members, ones that they can sell, they moving up or upgrading and those kinds of things. So I'm going to sort of suggest you do that. Alvaro, we were kind of looking for a feed from you. Can you get it or no? Is it?
Oh yes, let's see. Yeah, we have a feed up. 1 second.
I'm getting this really spooky cloud across the moon. It looks really super cool.
There we go.
Okay, there you go.
There it is.
So it looks to me like you have more of the moon is sort of like darkened out than me, right? I guess that would make some sense. We're just looking at the moon from it's definitely 2 different angles, but in the real angle or distance that we're looking at is not that much between us and you, I don't think, when you're talking about something.
I think it's still enough to note somehow, no, that there is a slight difference in how large is the shadow currently, but should be small, no, the difference. We have a kind of triangle, no, and we are looking from 2 different perspectives, but they are not too far away both, no?
No, not in the kind of this as far as the moon is concerned, we're just like right next to each other, I think. So
Exactly.
we
are forming like a very, very long triangle along towards the moon, no?
This is called interferometry, if I remember right. Okay, and so it looks like I'm going to start to have clouds drifting in, but it looks like it's crystal clear in Chile, which is exactly why you guys do your telescopes down there, right?
Yeah, exactly. I mean, that's one of the.
Just look at that. There's an airline just flew by. Did you see that going by my scene? So I'm going to actually, if you want to take a moment and just kind of reach out with your audience a little bit, I'm going to ask that we're going to get organized to get a gentleman named Claude Haynes on. He is actually out at Gilbert Observatory, which is one of those places where amateur astronomers are gathering to talk about telescopes that Sam E. might want to go talk to. So let me see
Rick, I can promote him if you'd like.
Yeah, that'll be all right if it can. Let's see if you can come on. I want to see what they're doing out there. Okay, am I the only one that saw the airplane fly by the moon? Is it just me? I guess we're recording this so we can go back and find. All right. Well, while we're doing that, Alvaro, I don't know. Do you want to do a Spanish break for a second?
Yes, that will be perfect. If Kata comes with me, then we can make a small upgrade.
Yeah, now would be a good time.
Okay, let's do a couple of minutes of this.
Okay.
Entonces, bueno, nuevamente para la audiencia que nos está siguiendo desde Chile y Sudamérica en general, lo que hemos estado haciendo hasta ahora es comparar dos vistas de la Luna, una desde Estados Unidos, donde como pueden ver ya está atardeciendo, está comenzando ya a verse la Luna con mayor contraste, y esta imagen que estamos viendo en este momento, que es la Luna como vista desde el desierto de Atacama, como les contaba antes, desde el Observatorio El Sauce, un pequeño telescopio que está ahí siguiendo la Luna, y vemos aquí mucho mejor el contraste de cómo se ve la sombra de la Luna con respecto también al entorno que ya está completamente oscuro. Y estábamos conversando sobre las pequeñas diferencias en qué tan ensombrecida vemos la Luna cuando se ve desde Estados Unidos y desde acá en Chile, dado que no estamos en la misma longitud. Ellos están en este momento, sobre todo en la costa oeste de Estados Unidos o hacia la costa oeste, y por lo tanto ven la Luna desde un ángulo que es pequeñamente diferente al que tenemos nosotros, y por lo tanto no vemos exactamente el mismo nivel de iluminación y de sombra, ¿no? En el disco de la Luna. Así que no sé si...
voy a hacer un resumen.
Por favor.
Sí. Bueno, básicamente están muy felices de participar en este programa. Ellos son de la Universidad Estatal de Arizona y hay un astrofotógrafo que está ayudando a transmitir las imágenes, tanto de Estados Unidos como de acá. En el caso de acá de Chile, están en el observatorio El Sauce, y van a transmitir bueno, ya dijiste parte de todo, que están transmitiendo parte del eclipse, que ahora mismo está en la parte de la umbra, que eso es como lo más importante. Eso, sigue tú.
Super, perfect. So I think we give the pass to Rick, if you are there, Rick. Bueno, si no, quizás puedo continuar, puedo contar algunas cosas. Como les contaba anteriormente, el eclipse parcial ha comenzado, como ustedes pueden ver, hace casi 10-15 minutos. Y ya tenemos casi un tercio de la Luna en las sombras, ¿no? Esto se va a prolongar más o menos hasta unos 20-25 minutos más, en que ya la mitad de la Luna va a estar totalmente cubierta por la sombra de la Tierra. Va a haber entrado la Luna en el cono de sombra de la Tierra casi en su mitad, y hacia las 11:30 vamos a presenciar la totalidad, que en el caso de Chile, dado que estamos más hacia el este con respecto a Arizona, va a estar más o menos pasando por el punto más alto en el cielo, o sea, va a estar casi cerca del meridiano, o sea, una posición, digamos, muy apropiada para la observación directa, observación con prismáticos, telescopios, lo que tengan a la mano. Y por el lado de Arizona, la Luna va a estar ya habiéndose desprendido un poco del horizonte, dado que habrá pasado casi una hora desde que salió y desde que comienza a anochecer por allá. Así que, bueno, tenemos que seguir aquí esperando a que esto progrese, y para que podamos ver aquí a través de la imagen, y por supuesto en vivo, si es que tienen la opción de salir a un lugar despejado y que no haya nubes, van a poder ver directamente la Luna y su característico color rojo una vez que alcancemos la totalidad.
Excellent. Hey, thank you very much, Alvaro, and I really appreciate it. I really love if you would pass along one of the things we were trying to achieve tonight is just make sure sort of people know that the world is a lot smaller. I mean, that's what we were talking about, right? It's a lot smaller than we think. We're all part of a bigger universe. We both own the moon, and so it's shared by everybody. We all sort of appreciate what's going on and what's happening. As you can see on my moon, right here in Cave Creek, I'm starting to get some clouds drifting by. It's happening a little bit more and more. So we'll just make sure that we keep your view available to us, just because you've got better skies, I think, right now than I do. I wanted to just take another, I'm going to just kind of move over to the LROC team, Lunar Reconnaissance Orbiting Camera. I think this is a really good time to take a little moment and see some of the research that they're doing. I'm also going to invite people, I don't want to say now that I'm introducing LROC to go leave or whatever, but I wanted to remind you over the course of the hours or something like that, find time to get out in your own backyard and take a look at some things. Find time to don't just kind of be on our screen, watch what we have to do, keep it on. If you can actually take your webinar device out in the backyard with you and watch the moon as we're talking, that's really the best thing. But I don't want to sort of like keep you locked in your house when the phenomenon is happening outside. So anyway, let me introduce the LROC team, and you guys have the floor for a little bit. Thank you.
Hi, everyone. I'm Jessica Walsh with the Lunar Reconnaissance Orbiter Camera at ASU. I'm here with Tom and Mariah. And I think we'll start with what even is the Lunar Reconnaissance Orbiter Camera. A lot of people have not heard about what we're doing. So Tom, do you have the presentation up?
I do. Hi, everybody. Let's see, how do I get this going? Are we seeing this?
Yep, we can see it.
We got it. All right. Hi, everybody. I'm Tom Taberzi. I'm a research technician here at the Lunar Reconnaissance Orbiter Science Operations Center. My personal job is taking high-resolution stereo imagery and making them into digital terrain models of the moon. We may talk about that later in the night. But first off, I'm just going to give a brief introduction of what LROC is. So LROC stands for the Lunar Reconnaissance Orbiter Camera. It is a suite of cameras on board the LRO spacecraft, which launched 13 years ago. The suite of cameras that this instrument is made up of is one wide-angle camera and two narrow-angle cameras. The narrow-angle cameras are push broom panchromatic, which basically means black and white images. The WAC is broadband, 7 bands of light camera. So here are a couple of things that we make. With the LRO camera. The left is the near side of the moon. It's a mosaic of images taken by our WAC camera. The right image here is a recreation of one of the famous Apollo images called the Earthrise. So this is, we took this image, it's actually kind of a composite image. It's a NAC camera that we slewed the spacecraft to take an oblique angle of the moon's surface. And then we overlaid some wide angle camera, some of the colors that it sees on top of that NAC image. Here is a close-up oblique image of Tycho Peak. It is about 10 kilometers in length, kind of deep here. It's about 3.6 kilometers off of the bottom of this crater that it's contained in. You can see this little boulder right at the top of this peak. I don't know if you can see my mouse. That is, oh no. That is a boulder that's about the size of a professional sports stadium. So American football or football, it's an enormous boulder on top of this mountain. The mountain is again 3.6 kilometers high off of the bottom of this crater. That is about the same size, the same elevation as Mount Fuji in Japan, which is huge. So here one of the things we do with the LROC camera is we take images of our Apollo landing sites. So here's Apollo 11, where we have some kind of mapped out landmarks. And on the right here, we have a composite image of a bunch of NAC photos so that we can see the descent stage of the Apollo 11 lander that was left behind. That's all I have for kind of the brief introduction of LROC. My colleagues have anything to add?
Go ahead.
Sorry.
Go ahead, Jessica.
I was going to say, if we have time, I have a presentation about some LROC discoveries, or we can save that for the next portion.
Let's hold for a second. I've got two things I want to do, but why don't you guys just stay really close? Thing number one is wanted to remind the audience, and I'll just keep doing this over and over again, is that there is a question and answer tag on your screen. So if you just have anything you want to know, if anything Tom said sort of makes you want to ask the next question about some of the work that they do, please feel free, and we'll bring some of your questions right onto the screen here. And address them live, or sometimes we address them in the background and just kind of like make sure you know what's going on. I just want to show everybody it's looking darker and darker and darker now on the moon. You can still see the edge every once in a while on my view here. And so anyway, I'm just going to leave it on. I'm just going to say that's the moon and that's where it is. And if the cloud's clear, you're going to see it. But I also, if you guys hang on for just a second, I wanted to go see if I could get Claude Haynes on board. Claude, I know you've sort of been in the background over there, and let's just make sure we can see you and hear you. And you're out at Gilbert right now, right? Is that right?
Right. I'm at the observatory, and I'm going to try my cameras if it's going to let me do that. And there we go. So we have the observatory open. We're not able to look at the moon because of the walls, so things have to be at least 15 degrees above the horizon for us to see them. But I am going to walk out and just give you kind of a look at the crowd.
I want to see a crowd of happy people. Look at them. Okay, there you go.
We have a big crowd of happy people as I wander down. These are the folks that are waiting to look through the telescope.
Okay.
And we have a good group of them. And then I'm going to swing over here, and if I can just swing between you folks, here we have on the lawn maybe a few hundred people, and we've got like 8 telescopes from the East Valley Astronomy Club.
Okay,
I'm afraid it is getting dark and it's going to be hard to see, but
that's all right. It looks to me
I'm not
like
getting much attention here, but we do have a good number of folks here. And as we go over, you can see there's the moon, and you're seeing a good shadow. The problem we're having, it is fairly clear here, but the issue is going to be we do have some trees that have grown up around the observatory also. But we're having a really fun time here with a lot of folks here at the observatory. I'll swing around this way, and you can see the dome. So it is a wonderful, fun night and perfect timing. Oftentimes, lunar eclipses are early in the morning and hard to get to, but we've got a lot of families out enjoying lovely weather. Unfortunately, the sun's lost, but hey, things happen. And really enjoying a beautiful night at the riparian preserve.
Excellent. Well, Claude, I think that's great. And it's sort of, we had somebody on board here asking a question about sort of how to get to know telescopes and how to talk to people that know amateur scopes and stuff. So I'm sending everybody over to you. So you guys, so can you tell me at Gilbert, this is like almost, do you meet every week or is it just every once in a while? How's that work? Claude, can you hear me okay? Maybe we've lost him.
Sorry, Rick, I'm losing your audio, but now try again.
Oh, I'm sorry. I just wondered if you could just tell us really quickly how often you guys do telescope time at Gilbert Observatory. Is it every week or is it more periodic? Oh, I'm afraid we don't have really enough signal for this. I'm sorry, Claude, but thank you for showing us around. Thank you very much for giving us a view of the crowds out there. I can see that the moon's coming up, and you got better skies than I do right at the moment. And oh, look at that! Actually, my view got a lot better. So anyway, I'm going to kind of switch back over, and Jessica, if you'd like to just sort of like kind of take the next segment, and we have to. So we have to kind of like get prepared for another thing at 8 o'clock. So you've got about 5 minutes if you like.
Okay, I will try to go as quickly as possible. All right, so I'm just going to do a short presentation on some of the amazing discoveries that LROC has made within the last 13 years.
It's spooky looking.
Can everyone see it?
Yep, we can.
All right. All right, so the first thing is some of our images have taken, these images that specifically that I'm going to be showing you are probably from our NAC camera, our narrow angle camera. It has a resolution around 1 meter per pixel. So they are very high resolution, fantastic images. The first thing that we have taken great images of in the last 13 years are called irregular mare patches. They're believed to have erupted as recently as 100 million years ago, which is really geologically young. And I have a short video to play. This is kind of a zoom in on one of our images that we've taken. This one in particular is called Aina. There's a scale bar down in the bottom right of this video that shows how big it is. And I'll just read the caption along with it. Thought to be composed of basaltic lava, similar to the surrounding mare that it's found in. The imps, or what they're short, that's what the short name for them, are both rough and smooth. And they're still strange. We're still trying to figure out what's going on with them. But that's the first discovery. And then another thing that we've been taking great images of is these permanently shadowed craters at the South Pole, minus 388 degrees Fahrenheit and colder. We think that this is probably a great location for some water ice on the lunar surface. And we hope to send some astronauts there to check it out. And this year we're actually launching another camera called Shadow Cam to look closer into these permanently shadowed craters. We've also been taking images of young craters, all the craters on the moon. They didn't just get there millions of years ago, they still are occurring every single day. And the Lunar Reconnaissance Orbiter camera allows us to take images from last year and this year in the same spot and overlay them, and we can actually see new impact craters all the time. We've also been taking amazing images of young thrust faults on the moon. We have seen that this is probably from global contraction. The moon is shrinking as its interior cools. These are small and crisp features. They're very young. And we think maybe if you were standing close enough to one, you might feel a moonquake if you're standing near these fault scarps. Another crazy discovery is these lunar pits. I don't know if most of you have ever seen lava tubes on Earth. There's a great one in Arizona up near Flagstaff, but we have seen these with our narrow angle camera. They're very large, even though seeing them in the images, they look pretty small. We've found over 300 to date, and we think that maybe they might be good shelter for future astronauts to protect them from solar radiation. But we don't know how big they are. They could just be collapsed pits. They could have huge lava tubes, tunnels underneath them. We're still trying to figure out how large these features are. And then lunar swirls. These are high reflectance or high albedo features that are different from the surrounding mare. they are associated with magnetic anomalies, but we still don't know exactly how they form. We know that there's some sort of magnetic effect going on that protects this area from the solar wind, and keeps some of this area relatively bright compared to the area that it's located in. It's also one of the highest priority targets for future human exploration and also robotic exploration.
Thank you, Jessica. Oh, my moon is sinking. Let me see if I can catch it again. Oops. When we were kind of getting ready for the program, I was talking to your group, and the subject came up: what does the Lunar Reconnaissance Orbiter do during an eclipse? And do you can you tell kind of real quickly what that looks like, and does it take a lot of pictures, or what does it do?
Well, I actually have a presentation prepared for that, about 5 minutes long, if we've got some time for that.
Oh yeah, let's do that. Okay, let's cover that afterwards then. I'm glad. Okay, I'm glad you're able to do that, because I think the audience will find that interesting, and so we'll go with that. All right, everybody. I'm going to just start to wrap up the hour a little bit here. Let me just kind of like go back over the timeline. We've got about 5 minutes until 8 o'clock. And if you've been sort of like following, of course, the moon is up. Now mine has sort of moved back out of the clouds a little bit. So we've got a nice little view. Remember that sort of little dark, shadowy, sort of like a nebulous kind of look to the moon we had about 15 minutes ago. Now it's starting to show more of a defined edge. And what's happening here, of course, is the moon is moving into what we call the umbral shadow, the darker shadow of the Earth, and it's getting to be about halfway there. So right now is 8:52, and on my little chart of things going on, we should see the greatest the part of the total eclipse at about 8:29. So we've got about half an hour for this shadow to keep moving apart. What I want everybody to watch for as we do this, and of course, again, I'm going to say, step outside, use the question and answer button. We got to keep this going throughout the whole thing, but step outside and look at the moon. But you're going to start to notice at some point, the moon is going to start to turn kind of a reddish orange color. Right now, from my point of view, where I am, I've got about half a dark moon and half a very white silvery moon, like it kind of looks normal. So watch in the next half hour as you're sort of observing the moon, and sort of see if you can identify the times that it sort of starts to go, when it actually starts to go into that orange or red phase. In just a moment at 8 o'clock, in just a couple minutes, we're going to go back and rejoin Lowell Observatory. We're going to have a dual audience across both systems. And I'm going to ask them, they also sort of had a partnership with Texas, another observatory, and we're going to see if we've got some views from there. I'd like to see what's happening in Party Land at Lowell Observatory when we get there. And then when we come back for the second hour, so we'll spend 15 minutes in partnership with Lowell Observatory. During that time, we'll go back down to Chile and sort of like just see how things are going down there with their moon. And this is our chance to sort of like learn a little bit more about Lowell and their ongoing programs, a little bit more about ASU and its ongoing programs. And so you've got like 2 minutes to go out and just kind of view the moon real quick. And I'm going to ask my team, Alicia, Alex, if we have any questions we can answer just for a minute or two before we go live with Lowell on both feeds.
We've had a lot of great questions. We have some regarding more about the Lunar Reconnaissance Orbiter camera and its team and Good. How they work. Fred actually asked, do you study spectral lines from the LROC?
Jessica, can you take that one, or you want to take it later?
I'm not exactly sure what he means by spectral lines. We mostly study lunar geology through our cameras, which take them in black and white images, and then our 7 different band images. So
I think the question, it's related to the same thing. So basically the spectral bands that you guys use are outfitted on this particular camera are tuned to sort of like help with the focus on geology. But all of your stuff is in visible light, if I remember correctly, right? You're not in infrared and other areas, is that right?
Yes.
Yeah, so 7 spectral bands of visible light, I think is what I would remember from that. We can reattach to LROC in the second hour as well. Okay, audience, keep doing that. Keep kind of pushing some questions into the question and answer. Alex and Alicia, keep bringing them forward as they come in. We're going to do that. Now I'm going to welcome back to the screen Kevin and John. And you guys look exactly the same as you did like about an hour ago. So
we were going to switch positions to see if you noticed.
see
if switch shirts or something like that.
So let me kind of turn my image on here for a second. So you
that's
can
a cool glow.
You can tell I am actually outdoors, right? I'm out. Let me see if I got a little.
Rick, it looks like you were eclipsed.
I don't like that. Yeah, no, I'm going to leave that off. Yeah, I'm actually outdoors. And I just have to tell you, there's a little thing going on in the background up in Cave Creek at this particular place. The frogs have just started singing. And so if you hear, can you hear it a little bit? So
the audience is loving it. We've had comments saying we love the background noises from Rick.
Okay, so I apologize for it. It's something I can absolutely not turn off. So if it gets really, really bad, then we just have to close, I guess. But anyway, I appreciate that. Oh, you can see the moon kind of over my shoulder over there. That's really super cool too. So, okay. Anyway, do we have actually a view of your patio? Do we have a view of the party there at Lowell Observatory?
I'm not sure if they're able to connect.
Okay.
We did have some clouds earlier, and there's clouds now, but we're able to still see it. It's really kind of eerie because of the cloud cover, but you can still see the eclipse. We're just looking at a screen here. And so you have the frogs in the background. You might hear some people in the background here chirping. We've got this big in-person event that I don't know how many people are out there, but based on earlier sales, we're probably have more than 1,000 people up here tonight.
Excellent, great.
And whatever the clouds do, we've tried for years to complain and to move them, but it just doesn't work. And so we're making the most of it, but we're still catching views of it.
Yeah, we got live music, toy performances,
it's
activity.
Sounds like you're more than just an observatory. You're the party on the hill.
We know how to celebrate space in Arizona. You guys are a couple, and you think about the heritage of space exploration. You were talking about a little bit earlier here at Lowell. Lowell's been here since 1894, so 18 years before Arizona was even a state.
Yeah.
You had cowboys and lumbermen and astronomers walking around Arizona.
What could go wrong with that?
No, it's really a great heritage. And in fact, the moon, again, as we're talking tonight, there's so many connections between Arizona and moon studies. Of course, you at ASU, down at U of A, up here in Flagstaff, the USGS branch of astrogeology was brought here in the early 60s to prepare the astronauts for going to the moon.
Right.
Every astronaut who went to the moon trained here in Flagstaff, learned geology. And then up here at the observatory, for a decade, the Air Force, a branch of the Air Force called the Aeronautical Chart and Information Center, a mapping branch, they use facilities here to map the moon. And I can show you, it's kind of hard to see, but these are these exquisite drawings.
Oh my gosh, hell yeah.
These are all done by airbrushes by hand. This is the Purback crater area. If you've ever looked at the Purback Cross, right around first quarter, it's kind of a cool feature to see. There's this great heritage of moon exploration in Arizona from all over the state.
You just reminded me of something. I know that you guys have a program where you do YouTube videos, and showing that particular chart, it would be really fun to do something with the reconnaissance orbiter people, LROC, because they have some of the most sophisticated mapping of the day. It would be fun to compare what some of those old airbrushed images look like actually sort of in new high resolution photography today.
And there are a number of nerds here I was going to say at the observatory, but I could narrow that down to in this room.
Yeah.
That have taken some of those maps and look at the LRO images. But you're right to, just from the screen to the map.
I know.
And it's remarkable. It's remarkable both what modern technology can do, but also what the illustrators of the 60s were able to do. The detail and the comparison is pretty striking, really.
Good. So here's what I'd like to do is, if you don't mind, can you spend a couple of minutes just sort of the very basics is, I would imagine a lot of our audience actually hasn't gone up to visit you yet, which is a shame because I visited Lowell ever since I was a kid. And I do love, it's a pilgrimage for me. I just love the place. I love what's going on. I know you got some new things up there. So can you just say, why does somebody want to drive out of Phoenix and come up there and visit you? Can they do it any day? And do they have to wait for an event? What's that look like?
Well, I'll let John say something about that in a minute, but I was going to point out that if you've been coming here since a kid, then you're dating yourself as younger than when the observatory was founded in 1894. So we're getting some, good idea of time here. So
my goodness sakes, you're a mathematician. You sort of put that together so fast. No, so John, why do I like drive up there?
Well, we're a modern observatory and a historic observatory. We've got it's the best of both worlds. We've got plenty of telescopes to view through up at our Godo right now, which is where our kind of live stream is concentrated. The Giovanni Open Deck Observatory. It's like a roll-off roof.
Okay.
Platform.
And that's new.
It's our newest.
Okay.
Beautiful telescopes, beautiful. And then we've got our Clark telescope, which is the oldest one on site. That was built by, commissioned by Percival Lowell when he first got here to view Mars, and we still look through it on a good night. We don't hide it away in a museum. We crack it open for the public to look at. I think you can come up any night that isn't a Tuesday. That's kind of our maintenance and training day. But yeah, the Clark is gorgeous. We've got plenty of telescopes and plenty of passionate educators. We're all a little bit weird up here in Flagstaff, and so we love the constellation stories. We love the science behind things. We get really passionate about it.
The observatory is also up on this thing called Mars Hill, right? So it's really right outside of Flagstaff. In fact, you can walk to it, right? But it's just
when Percival Lowell came here, he was looking for a higher elevation place, so he sent an assistant around Arizona Territory. This is 1894, so 18 years before Arizona became a state. And one of the places he tested was actually in Tempe Butte. So he did site testing there, but they ended up in Flagstaff, and we're 7,000 feet elevation. But at the time, he came out west because of the late 1890s, you were starting to get light pollution with electric lights starting to become commonplace along the East Coast. And that's where most observatories were at the time. So he came out to Arizona, there's no electricity in Flagstaff yet. So being close to downtown didn't matter for light pollution.
Right.
But as the years went on, it did. And then they created lighting ordinances. In fact, the world's first outdoor lighting ordinance was created here in Flagstaff.
I know you were the very first international dark sky community, if I remember right.
2001, yeah.
Now there are many, including Fountain Hills, right near us.
Yeah, Fountain Hills, yeah. In fact, our director, Jeff Hall, has worked a lot with Fountain Hills leadership and helping to make that happen.
I met him a little bit ago sort of about that. So, hey, I would like to use this opportunity while we have joint audience. Can I bring Chile back in? So I'd like to see if we can get Alvaro on the screen. And then kind of the same line of questioning is I think people can go down and visit astronomical facilities in Chile. And I think there's a really good reason to do that, if I remember right. So hi, Alvaro, how are things going down there?
Yes. So well, in Chile, it's also possible to visit some professional observatories in the north of Chile. Of course, you need to pick a date to go, and normally they are visits during the day, no? But on the other half, precisely in the region from which we are now looking, this nice image of the moon half shadowed already,
yeah,
there is a lot of many amateur observatories and many touristic observatories, because the north of Chile, the Atacama Desert, has now the image of a nice place to observe the universe. So there are many observatories making what we call astroturismo, no? So tourism with astronomy, and motivating people to go to the desert actually to have those views, very clear views of the universe.
That's excellent. So you're actually, I just noticed you're actually far more into eclipse than we are. Sorry about the frogs crash. You think somebody's being attacked on the patio here. So let me get mine back into view here. Oh, I guess they're actually kind of close to the same. I just was thinking you had a little more, and you can see I've got clouds again. And this is, I think you heard the guys describing Lowell Observatory and the history of it. And I was wondering if you want to just take a moment and do a little Spanish moment, if you want to kind of tell your audience a little bit about what that is. And then we'll be back in a second. I want to take everybody out to Tempe Town Lake because the people out there have a really cool thing going. So is that a good time for you?
Yes, perfect. I can take 2 minutes to summarize a bit what's going on in this transmission.
Thank you, I appreciate it. And then actually, I'm also going to ask Alex while he's doing this, if you, I don't know, did you get the Lowell feedback? Do you have their telescope view?
Not that I'm aware. Let me just double check to make sure that it's not back up.
And go ahead.
No. Yeah, no.
Ok. Bueno, entonces para la audiencia que nos sigue desde Chile y los que nos sigan en español aquí, les cuento que, bueno, como pueden ver en esta imagen, el eclipse ya ha avanzado bastante. La parcialidad va avanzando lenta, pero tranquilamente hacia la totalidad, que sucederá en algo así como media hora, 20 minutos más, va faltando poco. Prontamente van a ver cómo la luna se comienza a poner roja, ahora que ya solo queda una pequeña fracción de la luna por ser ya pasada la parte sombría. Y lo que se ha estado hablando acá también ha sido con respecto a los observatorios históricos. Nos hablaba hace un momento atrás, un rato atrás, desde el observatorio de Lowell, donde nos cuentan cómo fue la historia de este observatorio que surgió como un observatorio profesional hacia finales del siglo XIX, y que se ha ido convirtiendo con el tiempo también en un observatorio que recibe turistas, que recibe gente que quieren tener una experiencia astronómica, y entonces un lugar de reunión para los astrónomos aficionados y para todos los entusiastas de la astronomía. Y a propósito de eso, yo contaba cómo también en Chile, los que nos siguen de Chile lo sabrán bastante bien, tenemos uno, si no los cielos más claros del mundo, lo que no solo ha motivado que se hayan instalado observatorios profesionales, muchos de los grandes telescopios están acá, sino que también ha motivado toda una cultura de la astronomía en términos turísticos. Y así como tenemos observatorios profesionales, también tenemos un gran número de observatorios que hacen turismo en el norte de Chile y que justamente hacen el atractivo por la fama que tienen los cielos de Chile como una de las ventanas para mirar el universo. Así es que bueno, estamos en espera de la totalidad que sucederá dentro de poco y vamos a estar aquí siguiendo, digamos, esta transmisión en conjunto, mostrando cómo se ve el eclipse desde ambos lados, desde Estados Unidos, la costa oeste, y desde acá del desierto de Chile.
Thank you.
Álvaro, también agregar a esa misma información sobre esta cámara, es que hace 13 años atrás que toma fotos y que esta cámara camina sobre la luna. De hecho, esta cámara ayudó a sacar las fotos más famosas de la superficie de la luna, y que algunos descubrimientos que se hicieron con estas es que se tomaron sombras, se captaron sombras, y también se van a mandar astronautas allá para saber qué es lo que hay dentro de estas sombras. Y también captó algunos cráteres jóvenes y algunas llamadas fosas lunares. Y eso básicamente.
Súper.
All right, thank you. Hey, I just wanted to While I have you, I just want to just say, thank you for everyone in Chile that is watching and has joined us tonight. The spirit of the thing was to make this sort of two hemispheres and look at the same moon at the same time. And I'm going to ask John and Kevin if they have anything they want to say to your audience as well. And then if you would just translate that, and then we're going to move on to another image here.
Well, we're just pleased to as citizens of the world, no matter where we're located, to be able to look at something we can all see at the same time and to celebrate this together. So it's a real honor to be able to be part of this.
Yeah, I really appreciate all y'all and all the people viewing with us.
That's great. Alvaro, Katina, if you could just pass that on to your audience real quick, and then I'm going to change our view to Tempe Town Lake and see if we get some stuff out there. Please go ahead.
Sí, bueno, nos han pasado el mensaje de que independiente de los lugares donde estemos observando esto, lo importante es que lo estamos haciendo juntos y estamos celebrando juntos este evento astronómico desde ambos lugares y tratando de hacer que la astronomía sea una cosa que nos una, por supuesto, que es lo que hace, ¿no? La ciencia y la belleza de los cielos.
Thank you. That's excellent. Hey, can I see if the team is, Alex, you have the view from Lowell now? Is that what I heard? Is that right?
Yep. We have a view from them that we can share now. I'll put that up.
Can you show John and Kevin what they're looking at up there?
Yep, there it is right there.
Oh, there you go.
We got a view of the observatory and some of you can see on that top left corner, some of the telescopes being used.
Are there any people in there? I see it. Okay.
You can kind of see shadows mulling around. I think those are people.
Moving around up there?
Yep.
It's legit. You got something going.
It looks like it's cleared up some because it was pretty cloudy a bit ago. We couldn't see it at all 10 minutes ago.
It looks like my view is getting actually better as the night goes on too. So I think there's some high clouds.
Yeah.
Hey, I'd like to see if we can't get Tempe Lake. So John and Kevin, I know we're sort of on a little bit of a restricted timeline. So you can, thank you very, very much for having this opportunity to kind of like talk to us together. I think that's really super cool. And that's really what it was all about. And I think it's working. We've got lots of moving parts all over the place and you've got a big night ahead of you. So feel free to jump out as soon as you have to, but also why don't you help me take a look at Tempe Town Lake and see what they're doing out there too. So
Oh, hey, Rick, before our Lowell partners go, I'm suggesting that we do a virtual night sky and maybe we do a field trip and road trip up to Flagstaff.
you want to like maybe broadcast from up there to our audience?
Yes. I mean, you and I are taking some other road trips this summer to do the same thing. Why not go to Lowell?
Yeah. So Kim and I are actually going to be in Florida for a launch. We're going to do one of our programs from Cocoa Beach. So that'll be kind of fun. So
well, it's an open invitation. We'd love to collaborate more with you guys.
Yeah, that would be great. I would love it. So thanks for joining us tonight and thanks to our partners in Chile. This has been fantastic.
Super cool. We're not done yet. We've got a lot more to kind of take care of tonight just on our schedule. I know that John and Kevin, they might have to sprint here.
Yep, we're going to have to go now. So we'll just say thanks and thanks so much. Bye, nerds.
Thank you.
You guys are great. Okay. Say goodbye to my frogs.
We'll see you.
Okay. See you guys later. All right. Hey, let's see if Maitreya, Malhar, and Armand are like available. I know they were trying to get in a little bit ago. So
Rick, can you share your view while we're connecting with Tempe Town Lake?
Sure can. There's my moon. I might have to make another little adjustment here. Let's see if I can. I don't know. I'm sure you're all hearing the frogs. I'm gonna have to find out from Liz and James how they like put up with this.
It's a lovely chorus.
It is quite the little chorus going on. So what it looks to me like here is that we've got some high clouds that are just sort of fuzzing out some of the detail on the moon. Because I can see it still have a nice little sharp image. I think the focus is nice on sort of that outer edge around the outside. But we're really still looking for that time where now the dark side of the moon is going to start to glow in a reddish or orangish color. So so that'll be kind of cool. If you wouldn't mind, guys, if you would just kind of text over to the lake, and I know they're having trouble hearing our broadcast because we put them right under a freeway. So if you know, maybe we have to text them to sort of get them on board.
Yeah, we're getting a hold of them now.
And Alicia or Alex, if there's any other questions you want to bring forward while we have the while we're looking.
You know, we kind of have an interesting one. It's more a question, I guess, well, for you, but I guess anyone in our presentation that can answer. Sam's wondering, what is the most exciting astrological event you know of? I'm kind of curious to what some of your answers are to this.
Astrological event, or we'll have to say
astrological / astronomical. I feel
yeah, we're gonna have to say astronomical because we don't do the other one. Well, I'll tell you what. Two things come to mind. One is, I think I mentioned earlier, we had an opportunity. Actually, my wife and I had an opportunity to go up to Wyoming to see the total eclipse of the sun, and that was really very special. I'd seen eclipses before, partials and here and there, but to actually get into the track of totality and actually watch that happen was really you know, everything we expected and then some. But we also had an opportunity, it's astronomical, is we went up to Yellowknife, Northwest Territories. This is going to be about 5 years ago now, in the middle of the winter, and that was an experience. So Yellowknife is about the same latitude as Fairbanks, Alaska. It's way up there. You actually fly through Edmonton or Calgary, and then it's another, you know, 2-hour flight. And the aurora is absolutely stunning, and it's amazing, and that was really quite an experience. So, but then I guess the other thing I would say, just in general, I just love that people engage in this so wonderfully. I mean, the whole idea of astronomical knowledge and how it's affected cultures throughout the history and around the world. All of it is fascinating to me. So it's kind of making a little bit of a joke about astrological as opposed to astronomical, but the cultural phenomenon that people just sort of use the sky for many, many different purposes. And I think that's always just been fascinating to me. So I learn stuff every day, and I meet new people every day that have really good ideas and good passions. So it looks like we can't find Tempe Town Lake, is that right? We lost them? Poor guys.
Hope they didn't fall in.
We're still trying to get a hold of them.
Okay. I think what I might do next is let's go back to actually let's go check on Kevin O'Donnell, because he was actually going to show us some views through his eyepiece if he could. Kevin, are you on board? Can you come back in?
Yes, I'm here, Rick. I'll switch around my view. Did have some clouds roll in just in the last few minutes.
I know. Kevin, I think you have kind of the same clouds I do, right? You're North Phoenix and I'm north of Scottsdale. And so we're probably kind of have the same issues.
Yeah, I'm having a hard time sort of seeing my view too. Let me see if there's any way I can do it. Like yours is the main view I'm seeing right now. So I kind of wanted to move this around and show folks. Number one, it's live, but I'll give it a zoom in. Now, my other option is I can always switch over to a previous image from just several minutes ago. And therefore, I can get something that has a little more. I've been taking pictures all night. So, are you able to see that?
Yeah, I can.
Tempe Town Lake's joining him too.
Okay, good. All right, well, that's a good view. So I think what the audience is seeing now on the screen is that's the telescope view from the team at the students that are out at Tempe Town Lake. Are you guys in a position where you can get on screen and talk to us for a second?
Yes, we can, but it's really dark out here, but we'll try.
Okay.
Can you see us?
I'm glad it's dark out there. I don't think we can see you. No, actually, all I have is the lunar view, but not anything up in the screen. So tell me, Maitreya,
people stopping here by, and there's some people who are like stopping here from 7 p.m. They really want to wait until totality hits, so like it's pretty good.
That's good. So that's really what I wanted to see is if anybody is just kind of walking their dog and hanging around and sort of like just asking what's going on. Are people looking through the telescope with you?
Yes.
Yeah, we have about 20 to 30 people here right now. Telescope set up and a couple binoculars as well. So everybody's getting to see this amazing lunar eclipse.
What you should do is see if you can kind of get them to turn their little lights on their cell phones and turn around so we can see some faces. So, or just to at least see people out there. That's great. So I guess we found a good location at Tempe Town Lake. We were actually, Maitreya and I were out there on Friday searching around to see, you know, where's the best place to set up, where are we going to get some people. I can see that according to my watch, the shadow should be in totality here in about 4 minutes at 8:29 is I think, and it looks to me like it's moving fairly fast. Kevin, if you wouldn't mind hanging on for a second, I'll get back to you in a minute. But and then Kim, if you wouldn't mind kind of pinning these two images together, if you can pin them both on the screen, what Maitreya and team is showing, and then my image from up here. It looks almost the same. I think I might have a couple more clouds, but let's just kind of like hang here and watch what's going on, because I think as we do this in about 4 minutes, the moon should completely disappear. And I'm surprised, I can see it maybe in Maitreya's image a little bit. I'm starting to see that sort of red glow in the darker part, but I don't see it on mine yet. It definitely looks like it if I look at it live. So let me see if I can adjust my my temperature here. See if I've got some. I can get just a little bit more sort of the highlights here. This is almost spooky looking again, right? So. Alvaro, can you come on real quick, or can you show us your view from Chile real quick? Maybe Kim, I don't know if you can do this, but maybe you can pin all three on the screen for us.
I don't think we have it set up to where we can have all three, but we can share either ours or the Tempe Town Lake crew, or not ours, but Tempe Town Lake crew or the Chile telescope.
Look at mine is just about
to disappear. Share simultaneously.
I don't know if I know it's possible in some instances, but I'm not sure if it's possible. I can save you some time. Currently, the stream from the Chile telescope is dark. The moon is not showing up, I think.
Okay, it might just be that
it's just the exposure.
It's not showing up because it's completely dark. I can just still see just a little tiny sliver. And Maitreya, I think you get the best view so far. It's sort of that thing. I just want to see it go dark for a second. Checking my watch, it looks like the timing is right. We've got another minute here. And so for those that are sort of just tuning in, or if you've been going in and out and watching and all that stuff, what's happening now is the phase where the entire moon is actually in what we call the umbral shadow of the Earth. And so there's a penumbral, which is bigger and a little bit lighter. It just gives the moon kind of a dusky color. When it moves into that center circle, that's when we have totality. And that's the sort of the point we're in, just entering right now. You can still see just a little edge. If you can see this live, what happens, I'm just turning around to see. is when you find the moon in the night sky, it really has this really spooky kind of orange glow. Some people call it the blood moon or a blood red moon. Sometimes they do that. And what's happening there is that the light from the sun is actually passing through the Earth's atmosphere, and it's bending just a little bit. And so just exactly the same phenomenon that causes a rainbow to happen as the light passes through moisture in the atmosphere, it breaks up the colors, right? And so you see sort of the reds and the greens and the blues separate a little bit. The geometry of the thing is that as that light passes past the Earth through our atmosphere, it bends in just a little bit and throws some of that red light, the red light and orange light, onto the surface of the moon. So normally you don't see that at all, right? Because the moon is so bright and the sun is reflecting everywhere. But this is an opportunity to see that phenomenon. And that would have been very spooky in old times, wouldn't it? To see sort of the bite taken out of the moon, to see it disappear before your very eyes, see it sort of like turn red in the night. And then eventually, of course, it will come back and be the normal moon again. I'm just kind of centering my view here just a little bit. For the team at Tempe Town Lake, now they've gone completely dark. I can't see them at all. I'm just able to manipulate my light just a little bit, not very much, so that I can still sort of show some moon color up here and some of the saturation. I'm not getting as much of that blood red color as I'd like. Anyway, that's probably it. That's what we're going to get. That's going to be a passable sort of view for the time being. So now what happens next? Well, on our broadcast, we have some other things to show you. I've got a little demonstration that I'm using a different computer for to show you sort of how these things align and what's actually happening in space to make an eclipse happen. We're going to go back and share some time with LROC, the Lunar Reconnaissance Orbiter Camera team again. They've got some more stuff to tell us about. And we'll be checking in with other teams around as we can. We've lost the telescope feed from Chile, but we'll kind of touch base with them again as sort of the evening goes along, just to have more conversations with them. I'm going to leave my blood red moon up. And so I'm going to encourage everybody to hang out for a little longer because we've got some other things to show you. I'm going to encourage everybody, if this is a good time for you to just take a break, run outside, look at the moon because it is in totality now. It will stay sort of like this. It'll stay in this particular phase for over an hour. And so it will be at its greatest. It'll be in the center of the shadow at 9:11 tonight. So just about 10 minutes after 9. And we will be sort of wrapping up and sort of closing down our broadcast at about 15 after 9. So I'm just going to kind of leave this view up. It's a moon you don't see every day. It's a moon that sort of is kind of just in the throes of eclipse. But I'm also going to invite you to chat with us in the question and answer. Hang out with us because we've got some more to talk about, to see as the night goes on. And I'm going to just sort of also just say it's a good time to just go out and take a look on your own. Just make sure you're checking out your own moon when you have a chance to do that. Let me have the LROC folks come back if I can. And also while we're getting them on board and ready, I will just double check with Alicia and Alex to see if there's any questions that we need to answer.
You know, it looks like we've got a lot of. We don't have any questions at the moment.
Okay, that's
I get. Or here's one you might know off the top of your head. Keegan's asking: is the duration of lunar eclipses always the same?
Good question. And the answer is no, not exactly. The geometry changes just a little bit. But lunar eclipses are a phenomenon when we have totality like we do tonight. And when in our particular location on Earth, the moon sort of passes, sort of directly, the Earth is directly in between the moon and the sun. That's when it takes the most time. But the lunar orbit is really crazy and funny. Sometimes the moon moves a little bit faster, sometimes a little bit slower because it's an elliptical orbit. We do that too on Earth, but the moon sort of does that characteristic. So it all depends on, yep, three things are happening. Not only are we on the surface of the Earth and we're moving, we are also, the moon is also moving around its orbit. And of course, the moon, the position between the moon, the sun, and the Earth is always changing. And so you have to take all those things in total, and the total duration from very beginning to end on an evening like tonight is substantial. This is about as long as a lunar eclipse takes. But there are other instances where it just sort of like moves a little bit faster, or it's a partial, or it doesn't quite cover the whole moon. And so you see it sort of like take a little bite and then leave again. So all kinds of things are possible. It's a very complicated orbit. So that answers. All right, Tom, I see you're on board. Let's see, Tom, Nicole, can we get you back onto the screen here? I'm just going to leave my image up so it's in the background there. Thank you. Hi, Tom, welcome back.
Hello.
Hi, Jessica.
Hi.
So I know when we were talking.
Sorry, never mind.
Go ahead. I know when we were talking about the program this week, I know you guys have a tremendous amount of stuff to do. So I just wanted to sort of make sure we've got some more time for you to kind of show another presentation, another demonstration. I want to get to sometime the question about what does the camera do during an eclipse? We'll sort of like get there. And then I also wanted to just make sure that you're able to share some resources, some things that people can do on their own, you know, outside of the eclipse and outside of what's going on to learn more about LROC. So I'll turn it over to you guys.
Yeah, well, if we want to get to the talking about what we do with the camera and the spacecraft during an eclipse like this, I am prepared to
All right.
speak about that.
I can't wait to hear.
Let's see. Share screen.
Yeah, it's
All right. So I'm Mariah. I'm a research analyst here with the Lunar Reconnaissance Orbiter camera. I'm part of the team that tells the camera what to take pictures of and then gets those images off of the spacecraft once those pictures have been taken. So during an eclipse, you know, we've got a solar powered spacecraft. That's what these big panels are jutting off of the side of it here. That charges the battery when it's in the daytime side of the moon, which then allows it to run while it's on the nighttime side of the moon. And as you can imagine, during an eclipse, when the entire moon is covered by Earth's shadow, it obviously cannot use those solar panels to charge, which becomes a problem. So there are a lot of steps that are taken to ensure that the spacecraft makes it through this time where it can't recharge and can't really keep its heat in, so that when the eclipse is over, we can get things back up and running again. Yes, here's a little diagram. Obviously, no charging happening over here right now, what we're in. So the first step in preparing a solar-powered orbiter for an eclipse is to charge it up. We want to get as much power into that battery as we can so that it can continue to run its most necessary functions during the eclipse. The next step is to preheat it. Obviously, when it's in the shadow, it's not getting any charge. It can't run the heaters. It's also very, very cold. We don't want our instruments to freeze. That will cause a lot of problems with them. So we have to heat up the orbiter as much as is safe, because obviously we don't want things to get too hot either. So there's a balance there that has to be struck. The next step is to turn off all functions that aren't absolutely necessary to getting it through the eclipse. We're turning off all of the instruments. We're putting it on the absolute minimal amount of power draw that it can use. And once it's all shut down, it's taken a nap. Just got to fly through the eclipse. It takes a few hours, and then once the eclipse is over with, we get to check the power levels and the heat, make sure that everything is still able to run properly. It's got enough charge to start powering things back on. It's not too cold to where turning things on might cause problems that way. And it's kind of a gradual wake up from its little eclipse time nap. And then finally, we all take turns turning our instruments back on, checking things over, making sure everything's still functioning correctly at the end of the eclipse. And then we get to resume our regular operations and we can celebrate another eclipse survived.
Okay, so my great idea about taking a whole bunch of pictures because the eclipse is cool, that just doesn't happen, right?
Right. It can't take pictures during it.
Can't do it, right? It has to shut it down. Okay, well, that makes perfect sense, I guess, if you're operating an orbiter around another body. So I guess I can see this happening. So.
I think hypothetically you could keep the cameras turned on and point it towards the eclipse, but it would burn up the cameras.
Yeah, no, we don't want to do that. So no,
that might be an issue.
This actually sort of sounds so logical to me, of course, right? Because it's all solar power, right? So yeah, it moves into a shadow, then it stops working. I get so good. And so, but you guys, I mean, I think people don't know this very much, but you guys are kind of driving this machine, right? I mean, it doesn't do it itself. Somebody's controlling this mechanism and it's steering it through its orbits and turning it on and off and that kind of stuff. And so, Mariah, are you part of the team that does that? Is that what I understand?
Yeah, I am part of the team that operates our specific camera, the LROC camera. There are 6 instruments in the payload of the spacecraft and also 1 technology demonstration. So there's a lot of coordination between instruments, like who wants to get specific readings, who wants to get specific data, and we all kind of have to share the time spent using the spacecraft and making maneuvers and make sure that everyone can kind of get the data that they need. So there's a lot of coordination between all of the instrument teams involved.
I'll bet there is. That makes sense because everybody actually has their own data they're trying to collect, right? And so I get it. Well, that's really super cool. All right. I'm going to just real quickly, I'm going to kind of move over. I'm going to show everybody a little demonstration about eclipses. You guys can please hang on for that. And I'm going to just re-ask the audience if you have any questions about anything you hear tonight and want to kind of know more about it, please, this is a good time, or comment, or if you're enjoying yourself, if the moon looks spooky from your location, kind of like give us a little comment about it and see if we can get some of the communication going. So if you guys hold on just a minute, I think what I'm going to do is I'm going to switch screens over to another thing. I just want to kind of show you a little bit about why this is, eclipses aren't that rare, but they're also not that common. We're not out here every month sort of looking at this kind of eclipse. But it does happen often enough. Let me sort of see if I can do something. I want to show you, this is your Earth, right? And the program you're looking at here is what we call SkyScan, and it's Digital Sky 2 is what this is. And we use this on campus for demonstrations, for teaching, for education things, and that kind of stuff. And during COVID, I just was able to kind of take it home and use it. So this actually kind of is a way to fly around in space and see things real time. If I can get really, really, really close right here, I think you can start to see that there is I can actually point out, if you like, where Phoenix is. I'm sort of manipulating my little arrow here. So these two, there's Tucson right there, there's Phoenix right there. You can see that the shadow of the Earth, right, we have spun away from the sun. All the lights are on in the eastern part of the country, and it's dark where we are as well. So that's kind of a first little piece of the adventure. And then I'm going to back out a little bit and just sort of like show you a little bit more space out here. Pretty soon, your nearest natural satellite, the moon, will start coming into view here. I'm going to kind of move this way so you can see it. And I'm just going to, just as a little helper here, let me just add something. I just want to kind of turn the orbit of the moon on for a moment so we can see where that is in relation to the Earth. And so the Earth is in space orbiting the sun. The moon is in space orbiting the Earth. This is going to help a little bit if I just size up everything so you can see it a little bit better. And I'm just going to kind of move forward in time a little bit. And you'll see the moon basically orbiting around the Earth. If I adjust our view here, I'm going to just kind of flatten us out a little bit and move us over this way. The way the moon sort of like goes through its phases, of course, is it's always a relationship between us and the sun. So you see as the moon sort of moves around the Earth, it changes its location in juxtaposition to the sun all the time. When it passes between the Earth and the sun, that's that phase called the new moon. That kind of starts everything. When it passes around the backside, like right now, that's when we have a full moon. And the moon does this cycle about every 29 and a half days. It's kind of, this is not something that is unusual. That sort of happens all the time. There's a full moon every 28, 29 and a half days. And so why is it that we don't have an eclipse essentially every month? Why does that happen? Well, I can show you here in just a moment. I'm going to turn that off. I'm going to kind of go back to now so I know where I am. And I'm going to introduce you to sort of what we call the plane of the ecliptic. I'm just going to kind of put a sort of a plane across the sky. And what this is it's what we call the ecliptic plane. It's the equator of the sun shot out into space. And you can see that the Earth is riding right on that plane. As it moves around the sun, it never varies from that particular plane. It's sort of the Earth-Sun relationship in the Earth's orbit define that. But you'll notice that the moon actually sort of kind of breaks the rules a little bit. For a little bit of time in its orbit, it goes below the plane, and then you can see it kind of coming back out the top. I can darken that for you just a little bit and sort of like see how that, so the moon sort of rides above and then it goes down and goes underneath, right? And so I can show you that sort of view too. So there it is popping up again. And so where the moon crosses the ecliptic plane is what we call a node. And you can sort of imagine that as it's going down, we call that a descending node. As it's going back up again, we call that an ascending node. That means it's coming back again. But I want you to notice that the nodes actually sort of line up in space. And if I move over this way a little bit, you'll see where the sun is in this particular view. And you can see that where I am right now, I'm way up in time. I'm now in August or something like that. The moon, as it passes between us and the sun, is way above the plane. And when the moon passes beeline, it's way below the plane. You sort of see that happening. Let me go back to today, because I think this will be pretty clear. Let's look at that little spot on the moon. Here's what's happening now is the moon is in, the Earth is in between the sun and the moon. Let me flip around to the other side so you can see that a little bit better. And those nodes, the part where the moon comes above the plane and the part where the moon goes below the plane, is in somewhat of alignment with the sun. And so not only do we have the full moon, which happens every 29 and a half days, but the moon is at node. And that means that it is essentially sort of aligned with the plane of the ecliptic, and the condition that it sets up is that the sun, the earth, and the moon are all in exactly a straight line. So this is the phenomenon we call a lunar eclipse. If I just move ahead 1 month, I'll do it in about 5 seconds. You'll see sort of the moon moves in and then back to its same location, but the nodes are completely unlined now. So you can't, the moon does not share an alignment anymore. So that's really it. 2 things have to happen. Those nodes, right? The lunar alignment where it's passing through the ecliptic have to line up with the sun, and the phenomenon known as a full moon has to happen. And if those things, 2 things come together like they are tonight, that's what happens. Somebody was asking a little bit earlier about the plane, was asking about the duration of an eclipse. And I'd like to go back and sort of suggest that lunar eclipses, as like the one tonight, are going to last for about 5.5 hours, the total thing. It takes the Earth 24 hours to spin on its axis. So that means that we're lucky right now to have that 5 hours of lunar activity while it's nighttime on our side of Earth. There are people on Earth, right on the other side, in Africa and in Europe and in Asia, that are not experiencing this lunar eclipse at all. it started after sunrise back in where they are, and it will end before sunset. So they won't see it. So not only for you to be able to view a lunar eclipse do you have to have the full moon, the alignments of the nodes, but you also have to be on the right side of the earth. It has to, timing has to be right so that it's dark or nighttime where you are. And all of those things have to come together to make this happen. So that's really just kind of what I wanted to show you from the view of the Skyscan computer, what things are going on in space and what happens. And this is really one of the things to sort of take advantage of seeing an event like this and seeing and kind of participating in these things, is to ask yourself not only, this is really cool and I see a blood red moon and that's really unusual and I really like sort of seeing these kinds of things, but sort of turned on the wrong feed here. But it's also important to sort of ask what's really going on. What's actually that moon doing? What's happening in space to make this particular lunar eclipse happen? So that's my sort of campaign, to have us think about all that stuff and participate in these kind of things and phenomenon as we go forward. I'm going to kind of just sort of, I had the LROC people hang on for a little bit. I'm going to go back there, and then I also wanted to go back to Chile again before we sort of get out of our totality here. So LROC, would you come back to us?
And Rick, we have some poll questions too for both of our
Oh yeah,
partners.
let's do that. Thank you, Kim, for reminding me. Would we let's go to a couple of Lowell Observatory poll questions and see how they did that, and then we'll do some Chile poll questions when we get back to them.
It's going to be the LROC questions.
Oh, it is? Okay, I'm sorry. Yep,
That's
that's
so
perfectly
Lisa,
fine.
can you launch that poll?
All righty, that poll has been launched. The first question is, what do you see when you look at the moon? There is no right answer there. And then number 2, how many lunar pits have been found to date? Oh, and there's a third one there to surprise you at the very bottom. The tallest mountain on the moon is, and then you pick the blank. So go ahead and cast your votes there. And then don't forget to ask questions in our Q&A for our team. All righty, so it looks like a majority of us are participating. Thank you so much. I will close those polls in probably the next 10 seconds or so and share those results. But Alex, anything in particular in our Q&A we want to ask?
I want to know where mittens come from. Who did that? What do you mean mittens? Are there really mittens on the moon?
So a few people suggested that I put that in the poll. So
Okay,
I guess some people see mittens.
Well, at least 2 people also see mittens, so it's not a wrong answer per se.
Not a wrong answer. Okay.
I mean, you know,
All right, I'm going to share the results now for the LROC poll. Alex is right. 2 people do see mittens, so I'm glad we're super inclusive there.
I've never seen a man in the moon, so I just I want to say.
Neither have I. I always see the rabbit in the moon.
Oh, you see the rabbit? I don't. I just see dots, spotches. So tell me about the lunar pits. This was part of your presentation, and it looks like there's some sort of division about what they think here. What is this?
Yeah. So if people were paying close enough attention, it was, or were here during that presentation. There was the number right on the screen. We have found over 300 pits. So not quite 1,000 yet. Hopefully, maybe we'll eventually find 1,000 lunar pits.
And then what was the last one? Oh, the mountain on the moon.
The tallest mountain on the moon. Most people said about the size of Mount Fuji, which I think is kind of a trick answer that I put in there because of Tom's presentation. He mentioned that his mountain that he was showing was about the size of Mount Fuji, but that's actually not the tallest mountain on the moon. No.
Showing us the tallest. I get it.
Most of the tallest mountains on the moon are about the size of Mount Everest. Okay. And they're all on the far side of the moon.
Oh, okay. So we don't actually, okay. So we're not going to see them. Not without it, unless we had a camera like going around the moon in an orbiter. That would be
great. what if we had one of those?
What if we had that?
What if we have a presentation about LROC resources, I'll give a resource for people to zoom around the moon on their own and check out some mountains.
Good. I feel like I want to get back to Chile for a little bit. So if you guys stand by, we will have another presentation from you today, if we can do that. We've got enough time. And but I was hoping Alvaro will kind of join us again, and Catalina.
Yes, we are here. So do you want we explain a bit in Spanish to our audience, or?
Well, let me ask you first. I think
Yes.
Alex told me that we have your view back. Do you have what I was wondering is if you can see in your view, if you can see sort of the reddish kind of color. I noticed that we can see that visually, like by unaided eye.
Yeah. I just look over my window and I could see that.
You could see it, but
Yes,
I'm not necessarily seeing that in our images. I actually, I have to admit, I kind of cheated the camera a little bit to get it to look. Let me see if I can show you my view here real quick.
The Lowell feed from, they have West Texas on and it looks kind of orange.
Does it look orange? Can we see that one on the screen? Because mine is worthless. It's not doing anything. I'm back in. I'm back in shadow again.
Camera from Chile is a monochrome camera.
Oh, it is. Okay.
Yes. So that will explain the.
That's probably what tells you. And then Alvaro, it kind of looks to me a little bit. Oh, you know, I don't know about this. This looks a little fakey too, doesn't it? But,
I think they might compensate for an exposure as well. It seems it's a lot brighter than any of our other cameras.
Go ahead.
I can share mine. Mine's pretty orange, Rick, if you
Okay.
like.
Yeah, thank you. Sorry, Kevin, I know you're sort of out there in the field. You got a whole different view than the rest of us. Let me see what that is. And so, Alvaro, you're correct. In a moment here, oh, look at that, actually. So Kevin, you're not doctoring that at all? I mean, is what are you using?
No,
that's the color you're seeing?
So what I'm doing is, that's the color of the camera. It's a 2-second exposure, and it's kind of remarkable, you know, what you see when you can get just a couple of seconds with a color camera.
Yeah.
Really, the reason I got turned on to astrophotography was because the first time I took a picture of Orion and just took even 2 seconds without a tracker, all of a sudden there was purple and pink, and I was thrilled. And that's what I was just seeing about 15 minutes ago before the clouds rolled in with just a 2-second exposure of the moon.
Yeah, I'm afraid I'm a little bit too cloudy. I can't see mine at all right at the moment. So, well, that's interesting. That's really super cool. Anyway, so the Alvaro, did you hear my explanation about sort of why it kind of looks reddish? You're an astronomer. I'm actually an outreach person. So did I have that right? Did that sound good to you?
Yes, the explanation for the colors. Yeah, it's basically the same explanation for the color of when the sun is getting to set. No, I mean, in any sunset, especially if you have a clear view to the horizon, you see this reddish color, which is pretty much the same color we see now on the surface of the moon. And the explanation, as you say, is that basically in our atmosphere we have this dispersion. No? We have some scattering, mostly for the blue light from the sun. So blue light gets scattered, spread around, and that's why we have a blue sky, for example.
Right.
But then the red colors that comes also with the solar light, they just pass through the atmosphere. So what we are looking now at is all the light which is passing like tangent to the Earth, and then it's getting kind of filtered. No? So what we get at the other side is just the red part of the colors, and that light is getting on the moon.
Somebody started some music. I think this would be a good time if you need to take a sort of a Spanish language break and chat with people, kind of give them an update on what we're seeing. And it looks to me a little bit, I don't know if you're seeing this, Alvaro, but it looks to me like you're starting to sort of show the lightening on the lower right side. In fact, it's happening really fast now. So that surprises me a little bit. I wouldn't have thought it would be there at this time. So it's surprising.
Okay, I can go for a couple of minutes. Now I can explain a bit in Spanish, so for our audience also. Entonces, bueno, les cuento un poquito para hacer un resumen de lo que ha pasado en los últimos 40 minutos de lo que estamos siguiendo en vivo. Tenemos que ya entramos en la totalidad. Entonces la Luna ya entró completamente en el cono de sombra de la Tierra. Y lo que vemos entonces es que la Luna se ha teñido con un color rojo. Y hablábamos recién, hace un minuto, que este color rojo viene del hecho de que la luz del Sol, que está en este caso, digamos, detrás de la Tierra, ¿cierto? La Tierra se está interponiendo en este momento entre el Sol y la Luna. Esa luz solar está pasando tangente a la atmósfera de la Tierra, en todo, digamos, alrededor de la Tierra, desde el punto de vista de la Luna, ¿cierto? Por el borde. Al pasar esa luz a través de la atmósfera sucede lo mismo que sucede en los atardeceres, que es el hecho de que la difusión en la atmósfera tiende a dispersar la luz azul, que viene toda mezclada, y por eso tenemos cielos azules, por ejemplo, mientras que la luz roja pasa directamente, y esa es la razón por la que los atardeceres se tiñen de rojo, y es exactamente la misma razón por la cual ahora la Luna se tiñe de rojo, porque es esta luz que está pasando tangente a la Tierra, pasa por una capa bastante gruesa de atmósfera, y pasa filtrada hacia el otro lado y cae sobre la Luna y entonces la tiñe con este color, que es lo que a veces hace que se hable de una luna de sangre. Les quisiera contar también algo que Rick estuvo mostrando anteriormente con unas gráficas de cómo es la geometría de un eclipse. Entonces se los quisiera resumir en 30 segundos. Así como la Tierra da vuelta en torno al Sol en un año, ¿cierto? Tenemos que la Luna aproximadamente en un mes, algo así como 29 días, da vuelta en torno a la Tierra. El plano de la órbita de la Tierra y con respecto al Sol determina un cierto plano que llamamos eclíptica, y la Luna orbitando en torno a la Tierra define otro plano. Y estos podrían estar alineados, pero no tienen por qué ser así las cosas, y de hecho están un poquito chuecos uno con respecto al otro, más o menos por 5 grados, que es un ángulo pequeño, pero lo suficiente para hacer que no todos los meses sucedan eclipses. Finalmente, las fases lunares son la perspectiva que tenemos de la iluminación de la Luna cuando da vueltas en torno a la Tierra. Entonces, a veces vemos la sombra que se hace, digamos, la Luna que se hace sombra a sí misma, y a medida que da vuelta en torno a la Tierra tenemos las distintas fases lunares. Como además el plano de órbita de la Luna en torno a la Tierra está inclinado, sucede entonces que hay dos puntos que se llaman nodos, que es donde la órbita de la Luna intersecta este plano más grande, que es en el que la Tierra orbita alrededor del Sol. Cuando sucede una luna llena, y justamente la Luna va pasando por uno de esos nodos, coincide con el plano de la Tierra en torno al Sol. Por lo tanto, geométricamente la Tierra se interpone justo entre el Sol y la Luna, y es ahí donde tenemos eclipses de Luna. Fíjense ustedes que 2 semanas después la Luna va a estar al otro lado, y probablemente se produzca un eclipse de Sol, porque ahora vamos a tener a la Luna interpuesta entre la Tierra y el Sol. Y si se recuerdan, tuvimos un eclipse parcial hace justamente 2 semanas. Entonces estamos viendo ahora la consecuencia de esto, que es cuando la Luna está al otro lado, pasando por su fase llena, y entonces tenemos el eclipse que estamos observando hoy.
Sorry, I lost my microphone button.
Rick, we have some poll questions for them.
Okay, we actually, you guys sent to us some poll questions, sort of about astronomy in Chile, and we'd like to sort of like put those on the screen, see if you can help us interpret some of these audience responses.
Yep. So we have 3 questions. Our first is, on what other planets are there total moon eclipses? Where is the Lowell Observatory located? And then what characteristics made Chile one of the best places for astronomy? And you have your responses there. And yeah, go ahead and answer that. Are you seeing the poll? Yeah. Okay. There we go. We're getting some answers in. So yeah.
I don't see. Oh yeah, they're starting to come in. Okay.
There we go. Perfect. Yep. So answer those questions, and then we'll share the results.
Okay, so I have to read this first question myself again. Other planets are there total lunar eclipses? Total lunar eclipses. Oh, that would have to be. I guess I'm not going to like I'm not going to weigh in until I see what the audience says.
I'm trying to think it over myself too. I have to review all my astronomy lessons.
Thinking how this works. Well, I hope everybody got the location of the observatory correct.
Yes, looks like most.
Yeah, it looks like we've kind of we have a good bit of response. They're starting to slow down, so I think we'll share the results.
So what answer were we looking for on number one? I guess
Correct me if I'm wrong. I think it might be Jupiter, if I remember correctly, because I think Jupiter, Saturn, Uranus, and Neptune. I think all the gas giant planets are large enough to where they can eclipse their moons. Now, it's not the other way around. You can't get solar eclipses, but you can get lunar eclipses. Am I right? Is that the correct answer? Whoever wrote these, I hope.
Yeah, that's interesting question, no? Because as you say, solar eclipses are much more difficult, no? You need the moon in this case, as in our case, to have the same angular size as the sun, which is our case, no? And not forever. It will get at some point too far from the Earth. For the planets, I would say probably Jupiter, large enough, no, to cast a large shadow, no, behind.
Yeah, but this is a good question because it had our audience thinking. Yeah, so
It
lunar
did.
eclipses, I would guess the answer would be Jupiter. If we're talking about solar eclipses, then it would be none of them because, yeah. And then it seems like 88% of you got the correct answer for where the observatory is located, Rio Hordado. And then, yeah, what characteristics make Chile one of the best places for astronomy? All the above. Yep. Clean skies, dry, high altitude, perfect. Wonderful for astronomy. So, yeah, good job.
Alvaro, can I ask you about Rio Hurtados, or is it, did I say it wrong? Let me see if I can pronounce that right. Hurtado. How far is that from you? I mean, so you do your work, I think, principally in Santiago, is that right?
Yes.
And do you ever have to go visit these observatories, or do you actually work at one or more of the observatories, or do you most of your work kind of at your office in Santiago?
Well, in particular, this one of El Sauce I never visit, as I mentioned before, is an observatory which hosts many small telescopes from people, amateur people of astronomy. But I have visited professional observatories. For example, there is one, it is one of the first in the country that is called La Silla. It's from the European Southern Observatory. But mostly astronomers, and that includes me, work with data which is not taken by ourselves. What we do is apply to observing time, and somebody in the observatory takes the data for you. So at the end, you receive the data remotely, and I could live in Santiago, or I could live in Punta Arenas, like one of the southern cities in Chile, large cities, and I could do astronomy equally well because the data comes to us, no? We don't need to go necessarily to take the data.
Okay. Well, that's good. Well, and then how long did you go to school in Chile, or where did you learn your craft?
To learn astronomy, you mean?
Yeah.
Well, in Chile, since I would say around 20 years and so, astronomy has developed enormously, mostly because undergraduate programs in astronomy has been opened in many universities. Now in Santiago, I could count mentally now quickly at least 5 universities or 6 just in this city that you can go and take a degree in astronomy, for example, as a bachelor. And in the last, I would say also 20, 15 years, many graduate programs has been started in the country. So you can do everything from the bachelor, master, PhD here. And that's very nice because it has created an ecosystem of astronomers working here, has attracted a lot of people to work here in Chile. Most of my professors in university were not Chileans. Now there are many Chileans in different universities, me included. No, it's getting massive this let's say, amount of astronomers per capita, no, in the different universities. And this was an effect of the universities taking the opportunity to start programs, taking the chance that we have access to observational time in the observatories. So it has been like a circle, no, of good decisions, let's say, by the universities, and feeding the country with fresh astronomers educated here in our own country.
That makes sense. And I know we were speaking before the show, but with many researchers at ASU, there's one in particular that studies exoplanets, planets around other systems. And I know that in order for her to do her work, they had to do it at, or they didn't have to, the opportunity was to do it at a telescope in Chile. And the research was amazing. I mean, they were using your amazing clear skies to look at planets orbiting other stars, which is, I still can't even fathom that, 20 years ago, I never thought we'd even be at the point where we could see that from an Earth-based telescope. But this technology is growing. It's amazing, and your scopes are available to people worldwide, which is quite something. And I'm really glad that your scopes were available to us tonight. I just think I lived a little lifelong dream of being able to sort of see the moon from both the southern hemisphere and the northern hemisphere at the same time. So I appreciate that.
That was great. No?
I would like to just kind of go back to another segment with the Lunar Reconnaissance Orbiting Camera. But then before we sort of close down for the night, I'll come back to you, Alvaro, and we'll have another quick chat, okay? So, thank you. Can we go back to the lunar team? I think you guys. Maybe they closed. Nah, maybe not. Hi, Jessica.
Hi.
So before we kind of close out, we're sort of coming to the kind of our designed end of program and broadcasting was going to be a little bit after about 9:15 or so. It's a little bit loose, but I wanted to just kind of touch base with you again and see if there's anything else you guys want to tell us about the orbiting camera and your work. And especially, I think we still wanted to kind of get to some resources that the public might be able to look up on their own computer and do things on their own. So
yeah, I'd love to share with the audience a resource that we use at LROC, our scientists use here, and really anybody can access this website. So I'll go ahead and share. If you can just type into Google LROC Quick Map, and you can click on the first link here, and it'll pull up this amazing resource to explore the moon. And it pops up and it shows you the lunar near side, but you can go in and you can change it to my favorite, which is the lunar globe. And once it turns into the globe, you can zoom out pretty far, you can zoom in, and you can get down to the narrow angle camera scale. So the super high resolution images, you can zoom in really far, and it'll resolve in a minute. Yeah, there we go. And then you can zoom in and out, and then you can also click on the moon and you can drag it. And we can only see the lunar near side here on Earth, but with Quick Map and with the Lunar Reconnaissance Orbiter camera images that we've taken, you can spin it around and look at the lunar far side as well. I think a lot of people haven't seen what the far side of the moon actually looks like.
No, and there's some new research over there right now, which is really kind of cool. So the Chinese have a lander on the far side of the moon. They're discovering sources of water. Yeah, so that's really cool. But so the skin we're seeing, the sort of the file that is sort of putting that's on the surface of the moon, does that come from your cameras then, right? Is this a wide angle camera?
Yes, this is the wide angle camera composite. The more you zoom in, the more it will be from the narrow angle camera.
No, I see. Here you go. And so it's a bunch of different data stacked in there. So as you zoom in, you might sort of be zooming into different data sets than you started at. Is that?
Yeah, the amazing thing about this application as well is that you don't just have to look at color or black and white images, you can throw on other layers. So we have Grail gravity data. You can see the gravity underneath the moon. You can throw on nighttime and daytime temperatures. And you can even throw on nomenclature overlays. So it can tell you what things are called around the moon.
It's amazing. And did you guys create this at LROC? Are you the creators of the program?
I believe that it was collaborative between LROC and some other organizations.
Okay. No, it is awesome. And it looks like somebody could play with this for hours and hours and hours and learn a tremendous amount about the moon, right?
Mm-hmm.
And it works on just anybody's home computer, basically. You need to have anything special?
You don't need anything special.
Okay. I think it's awesome.
I think I mentioned I'd zoom into some lunar mountains. I'll take you to the far side, and we'll go to SPA, the South Pole Aitken Basin. It's the largest basin on the moon. And a layer that I like to throw on is called shaded relief. And this just shows you the elevation of various points of the moon. We can zoom in here really far to a mountain. This is one of the tallest mountains on the moon. And you can even turn it so it becomes like a 3D model. And I'll take off the color shaded relief just so you can see the real images here. Somebody asked what's a basin. A basin is basically a huge impact crater. They're usually over, I don't know the exact number, but 200 to 300 kilometers plus wide.
Rick, you're muted.
I'm sorry, I'm muted. I've been making all kinds of wonderful comments about your program. So that's absolutely beautiful, Jessica. Thank you guys all from LROC for participating in our program. You always do amazing things. Every time we go to you to sort of like have you present, there's something new I learn about what you're doing, learn more about, and so how vital that particular research is. So I think it's really, really great that you did that. I'd like to just kind of go around and check in with everybody that still might be on. And we're kind of at the hour we were talking about kind of winding up the program. I would like to kind of go back to Tempe Town Lake and see what those guys are doing. I don't have a view of the moon anymore because of the clouds, but let's see what they have sort of at the lake.
Oh, because we're bumping into stuff.
No, I think how you guys doing? Are you guys at the lake?
Yeah, but it's really cloudy here, so we cannot actually get a view.
Yeah, I was just noticing I'm really, really cloudy here too. I'm having trouble with my view as well. I might be able to see if I can, wander around a little bit. Unfortunately, it's so cloudy, it's just hard to find it. So so for the audience, the moon is at the center of its eclipse happened about 4 minutes ago. And so now it's kind of moving across the darker shadow. And what will happen later is you'll start to see, we'll be off the air, but if you want to kind of get up and check it out in about half an hour, and then in about 45 minutes, you'll start to see the brighter side of the moon start to come into view again. And then it will take that same half hour it took to sort of like, or the same hour it took to kind of cover the entire moon will happen in reverse. And then the whole moon will be exposed again by the end of the night by about 11 o'clock or 11:15. So did you have anything, Matthias? Sorry, are you trying to break in?
अरे यार साइड पे वो लगे हुए होते हैं ना नीचे क्यों देख रहे हो अरे बस चेक कर रहे हैं कि कैमरा का सेंसर की मार्क तो नहीं छुदी वो चेक कर रहे हैं बेसिकली लेजर दिया ओह फक
I can't hear who that was. Anyway, well, thank you, guys at Tempe Town Lake. Thank you very, very much for joining us. Kevin O'Connell, are you still there? Do you have anything?
Just clouds.
Just clouds by now, huh?
Yeah, I mean, I'm happy to share the stuff I had in my deck that was like sort of processed finished images, but other than that, I don't have much else to show tonight.
Did you get any pictures? I mean, were you satisfied with the run? Did you get anything tonight that you're going to share with us later?
Yes, absolutely.
Okay,
there
great.
are some great photos in the first hour.
Good. Well, that's what it's all about, right? Sort of just getting there, getting at the right time. And so I think what we're, I want to have a segment at our Wednesday show on the 18th. We start at 7 o'clock. For those of you who want to rejoin us, and we'll be asking people from around town if they got anything, if they sort of, the amateur astronomers, what they saw, how they photographed, and if you can help us lead that that presentation, that would be great, Kevin. I really appreciate it.
Sure, happy to help.
Awesome. Sounds really good. Okay. Let me see. I think what I want to do is, I think, go back to Santiago, go back to Chile, and just say goodnight to everybody. Give you guys another chance to just kind of talk to your audience in your language. I'm going to ask Kim and team if there's anything else we need to do before we go. I do have one more video about the School of Earth and Space Exploration that I think we'll play at the close. If Kim, if you don't mind, and we get that ready. And but before we do that, I'd like to thank our friends at the Chilean Astronomical Society for joining us, and I appreciate you kind of coming back in and staying with us for the whole time, and really think this was a really successful night, especially the earlier views. So thank you. Alvaro, if you would like to take a moment to start to close out the presentation with your audience, that would be fine now too.
Okay, thank you. So, well, let me take first the chance to thanks to you, I mean, and to all the organization for inviting us also to share this experience of watching the eclipse from the two hemispheres of the Earth, and to share all together this experience overall. So thank you for that. And so, well, let me take 1 or 2 minutes just to summarize for our audience. So we summarize what we are now in the eclipse, and to say also bye-bye to them in Spanish. So
that would be fine. Thank you.
Cool. So, bueno, estamos ya dentro de la totalidad, ¿no? Entramos a esta fase hace casi hace 1 hora, y esto va a durar todavía por un rato más. Todavía va a ser posible por espacio de 1 hora, un poquito más, ver la luna teñida de rojo. Luego de eso ya comienza el proceso inverso del que vimos, en que la luna va a hacer nuevamente progresivamente salir del cono de sombra de la Tierra, y vamos a ver de nuevo que la luna se va volviendo progresivamente a iluminar, como lo estuvo cuando salió por la cordillera hace unas horas atrás. Así que este es el momento para sacar las fotos. Me asomé recién a la ventana, vi que hay algunas nubes sobre Santiago, pero intenten sacar sus mejores imágenes para que las puedan compartir y las podamos ver también en redes sociales prontamente, sobre todo en las redes sociales del Instituto Milenio de Astrofísica, a las cuales están muy invitados siempre a mandar sus imágenes y sus experiencias con respecto a lo de esta noche. Entonces, simplemente quisiera aprovechar de despedirme a nombre del Instituto Milenio de Astrofísica, de la Sociedad Chilena de Astronomía, también, que nos hizo el link para hacer esta actividad juntos esta noche, y dejarles la invitación a que quizás en alguna otra ocasión nos volveremos a juntar para observar un eclipse o algún fenómeno astronómico en conjunto, como lo hicimos hoy. Así que estén atentos a nuestras redes sociales y nos vemos en el siguiente evento astronómico. Así que muchas gracias por estar y disfruten del eclipse. Aprovechen de salir si es que tienen un momento a disfrutar de lo que queda del eclipse.
Thank you. Thank you. And I'm back. Let me switch cameras again. I just took a walk over and I'm searching the sky and I just cannot see the moon at all. So as far as Cave Creek goes and North Phoenix, we're kind of completely socked in with clouds now. I'm really, really glad we had at least enough time at the very beginning to see the moon rise above the horizon and see sort of the activity start. But it is the way that astronomical phenomenon happens, right? Sometimes it cooperates and sometimes the weather cooperates and sometimes it just doesn't. So again, for everybody that participated with us on the program, everybody that was a guest, everybody that kind of came on, everybody that worked hard to kind of go someplace and have a view and do the technology to get it to us. I just really appreciate all the help everybody gave. We will look for opportunities to do things just like this in the future. If you didn't pick up on it before, when I said it, every other Wednesday night, we have a more sort of regular broadcast for 1 hour at 7 o'clock. The next one coming up is on May the 18th. We will be showing people some images of what we found out tonight and some captures and some things that we talked about along the way, just as a recap, and we'll introduce you to some more night sky phenomena, some things to look at in the future. So on behalf of my entire team, Kim Baptista, Meg Hufford, Alicia Hyatt, Alex Blanche, the team that was out at the lake, Maitreya, Mahar, and Arman, really appreciate everybody joining us. And I'm going to start to kind of wind down and say goodnight. Before we actually go, I'm going to just double check with Kim one more time. Is there anything else we have to do? And then I have just a kind of a little, it's just a 2-minute video about the School of Earth and Space Exploration, about us, about what we do. We're a teaching institution first and we're an outreach institution after. And so I'm going to kind of close with that. Thank you, everybody, for joining us.
We were all good. And I just want to say thank you to everybody for joining us, our partners in Chile, our partners at LROC, and our partners at Lowell, and of course, my community outreach team. So thank you very much. And here's a short video to close us out about the School of Earth and Space Exploration.
See everybody later. See you at the next eclipse.
See you. Bye-bye.
Bye-bye. Thank you.
At Arizona State University. Here at the School of Earth and Space Exploration at Arizona State University, we are deeply committed to high-impact scientific discovery. We ask important questions with deep consequences for humanity as we explore the great unknowns of the Earth, our solar system, and the universe. Our students work with faculty in astronomy, cosmology, geosciences, planetary sciences, exploration systems engineering, and science education. We are breaking down the boundaries between these disciplines to answer the biggest questions that cannot be answered within a single discipline. Our degrees are designed to challenge students, to encourage critical thinking and scientific inquiry, and to inspire exploration. At the school, we're exploring all of Earth's continents and looking at the future in terms of climate and water supplies. We study astrobiology and seek to understand the relationship between life and a planet. We're at the very center of the community trying to understand whether Mars is habitable, maybe even in the present day. We have one of the largest collections of meteorites in the world, the largest at any university. And we have some of the best university facilities for building flight instruments and spacecraft for exploring our moon, planets, asteroids, and the unknowns of the universe. Here at the School of Earth and Space Exploration, we are combining the strengths of science, engineering, and education to set the stage for a new era of exploration of our Earth, our universe, and of the future.